You want to talk about the stick? Right. You want to talk about the USB stick or something?
USB.
Yeah.
Go on. Should. So we're ready? You're ready? Yeah? Okay. So thank you for coming back today. Today we have two topics. One is accessibility and individual differences, and the other is cultural differences. And, you know, I'm experiencing cultural differences here by visiting, but there's ways to talk about that that'll help when you're product designing. So one thing that's in accessibility is that, well, I'll get to that in a minute. Okay, first, individual differences. What are individual differences? This is a term from the psychology world that means ways that people differ, right? And you probably have friends who will say, oh, that guy is so good at navigating. He never gets lost, but I get lost all the time. People have differences like that. People have differences. Some are musicians, some are not musicians. So we all have differences. And when you're designing a system or a product, it's useful to understand those differences. So why do people vary, right? It could be different things. It could be genetics, like the music difference is probably genetics. It could be the environment. If you grew up in a really large family with like 12 kids, you might not have gotten as much attention as the only child in a family, and the parents are like, oh, my child, right? You know, so that's going to affect you. We're going to see some sad facts about age and getting older, and then, of course, expertise in your training. So here's what's interesting about aging. They have two kinds of information here. This is age on the x-axis, and these are normalized variables, meaning it's just they've taken a bunch of variables and all put them on this -1 to 1. And when they look at cognitive task performance, like how fast can you do a math problem, how fast can you remember a recipe or navigate, as people get older, they fall down, right? I mean, it's just, you know, I'm somewhere in here in the 50s, I'm like, oh dear, right? So I don't know about my future. But what's interesting with people who are older, like your parents or such, is the world knowledge keeps going up. So they keep having facts, but they're just not as fast at getting to them and using them. So when you're designing a system or a product, depends on the product niche you're in, but it could be that the people using the product are older. And are they older and they have money? Like some older people have more money, you know, they have a career, they've earned their job, they have their money. And so they're going to want the system to be easy to use, even though they have these challenges, right? Here's an example study where people were taught how to square a 2-digit number. So it turns out you can follow some of these rules. I'm not going to go into the rules, but you can pretty quickly learn how to square a 2-digit number and impress your friends if you follow this. And they taught this method to people in their 20s, 40s, and 60s. And so whenever you see a study or you hear about a study, it's useful before you see what happened to think to yourself, what do I predict will happen? So how do you predict the results will be? If people in their 20s and 40s and 60s had to learn this method and apply it, is there a difference? Do you think people? So maybe the first people are faster. And so what do you think would happen if they practice? What if I practice, you know, 5 times? Can I make up the difference and maybe I'm not hurt when I'm old anymore because I practiced? What do people think? Is it the practice effect will make the age go away, or the age will still be there? Okay, and this task right here. This is like, you know, following these rules of math. You think the age will go away? You think the practice will make it go away? Okay, we can be hopeful, right? Because if I'm older especially. All right, so let's see what happened. So we have the older people in the squares, and then we have middle in these diamonds and younger people in triangles. And they had 6 training sessions. And we're looking at working memory errors. So you make a math mistake, or there's calculation errors. The working memory error is like, I was working on the 7, but then I need to remember I'm working on the 7, and you do something else, you come back like, what was I working on? And you forget the 7. The calculation is, like I said, 7 times 2 is 15 instead of 14. So what's interesting is that in the first session, age is a big problem, right? The older people are a lot slower. But as they practice, per Prof. Mohit, right, the difference decreases. So the older people can practice and get almost as good as the younger people. And here, with the calculation errors, they do. So sometimes practice can help, but as you mentioned, it can depend on the task, right?
So it's I can understand the y-axis.
Sorry, say again?
So in the graph, the y-axis, it's not, why is it 2, 4, 6, 8, 10? It's the age.
That's just counting errors. It's like, how many errors did they make? Yeah. Yeah. Okay, so when you're designing a system, you can think to yourself, will it result in issues like this? How will practice help? Okay, so that's about age. Now, cyber sickness is a thing that I study a lot in my own research, which is about putting on a VR headset or an AR headset, like the AR glasses. And I would say there's 15 to 20% of people who will never get sick. And these people don't get sick on boats or airplanes or cars. They never get sick. And it's probably a genetic thing. And then there's about 5% of people, and you put a VR headset on them, and within 30 seconds, they're saying, take it off, I'm so sick. And most of us are in the middle a little bit. How many people have worn a VR headset? Okay, so some people. And I would say if you're going to wear it for more than about 30 minutes, most people start feeling a little off. Maybe just a little like, oh, something's not quite right, or maybe I'm sweating a little bit. Not everybody. And it depends on how well the software is designed. So what affects these are, you have to have good hardware. Most of the headset hardware is pretty good now. There used to be latency in the hardware, but we've gotten rid of that. The task matters a lot. So if I have a task that requires you to look in the distance and then look close, and then look in the distance and look close, you're going to be worse off than if it's just like scan in the front. And then people talk about optic flow. Have you ever seen a science fiction movie and people are in the spaceship and they launch into warp speed and all the stars go, right? That's high optic flow. So pixels are moving on the screen. Yeah. So if you have high optic flow, your brain tends to think that your brain sees that optic flow and it says, oh, you're moving. But your vestibular system in your ear says, you are not moving, you're sitting in a chair. And then there's a conflict. And when there's a conflict, then your body starts to say things like, maybe he ate some poison. Maybe we need to throw that up and get that out of there, right? And so then people start feeling nauseous. So it's this Q conflict, and there's also a factor of how good you are at balancing. So if you watch me and I'm standing up here and I were 10 years older, I might have trouble not moving. You see this with some older people. You see it with undergrads who don't know how to speak well yet too, but if I have trouble balancing, right, I might be oscillating more. And people who oscillate more as they're standing there, and you see this sometimes with older people, they're going to have more sickness too. What's interesting is that almost all the studies talk about women get sicker than men. And there's a big controversy in this field about, is it genetics or hormones? Or is it the fact that, like if you, there's a thing called IPD, interpupillary distance, like how far apart your eyes are. The headsets are mostly built for men's eyes, right? And women's heads are a little smaller. Some of the headsets, you can adjust the IPD down, or it'll adjust automatically, and it's like, okay, I'm good for you now. But some of the headsets, particularly 3 or 4 years ago, wouldn't adjust. And so then you're a woman wearing this headset that's built, that's not for you. So then it's not that you're a woman that's making you sick, it's that it's not built for you. So there's some debate in the field about why these results are, but almost every study you do, if there's cyber sickness, women are going to get more sick. Motion sickness history is a big influence as well. So if I tend to get sick, then I'm going to get sick in VR, right? Yeah, okay. So one study we did was what we called the cyber sickness corn maze. So do people grow corn in India?
Yes.
Yeah? Okay, so there's some corn. And when you're growing corn in the US, it might get to be 3 meters tall, some of the tall corn, definitely 2 meters tall. And what the farmers will do sometimes for extra money is they'll carve out a maze in the corn, and then they'll invite people to wander through the corn and try not to get lost, and they find things. So we made a corn maze, and we had 3 kinds of tasks for people. One is they are just sort of sitting there and the corn maze is gliding by. It's like they're on a railroad through the corn maze. They're just watching, it's gliding by. And their turns. The other one is called zero back, and it's like every time you see a skunk, there were 3 kinds of animals. Every time you see a skunk, you click on it. Okay? And that's not that hard. It's like, oh, see a skunk, click. The 2 back is hard. The 2 back means only click on an animal that's the same animal that I saw 2 animals ago. Okay? This is the sort of task, if you make your friends do this, they will be mad at you because it's a pain in the neck. So if I see animal A, and I see B, and I see B, and then I see A, I'm like, oh, that's 2 back. That's the same as 2 back. I click it. Okay, then I get C, that's not the same as B. I get B, that's not the same as A, not the same. B is the same as B. I click it. So it's called a working memory task, and it's really hard. It's definitely working your brain. There's also 3 back. You have to remember 3 back, and that's extremely hard. Like, a lot of people just can't even do it. So here's an example of the corn maze. You have to ignore the words. When the people saw it in their headset, there were no words. So I think this might be skunk mode, or no, this must be the 2 back mode. And so now every once in a while there's things like you have to climb down a ladder in a pit. And the things we put in the corn maze are known to make people sick. So up, down will make people sick. And let me see. Yeah, that's all we got. We also had a trampoline where as you're going, it's like boing, 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 and that makes you sick. Okay, so our question was, will the working memory make you sicker? So if I give you this 2 back task that's taxing your memory and making you think hard, are you going to get sicker, or is it independent and it doesn't affect your sickness? So what do people think? Are the people in these 3 conditions going to get differently sick, or is it going to be pretty much the same?
I think the 2 back people will get because they are doing so much working memory tasks. The cognitive load on them is so much higher than the control and 0 back.
So you're voting for the 2 back people will get sicker. Okay, who agrees with him? Anyone? Okay, 2 back people get sicker. Sorry?
Sickness is dependent on the task which is given.
It's different than the task?
It is dependent on the task which is given to the...
Well, that's right, yeah. So you think it's going to be more sick on the 2 back? Okay, does anyone disagree? And they think, no, this task doesn't matter. If I get sick, it's really about how the world goes in my eyes. It doesn't matter what the task is.
So there might be a chance that if I apply some type of cognitive load like this one, there might be a chance that it might distract them from the artifacts that are causing motion sickness.
Exactly. That's a great point. And that's one of the things we're interested in. Like, when you're looking at the corn maze, what is making you sick? And it could be that I'm just looking for animals. And so, like, in the attentional focus area, I'm just looking, like, right here at the animals. So I'm not even seeing all that stuff going by in that corn going on. So maybe I don't get as sick. Yeah? Does that make sense? Okay, so this is the big reveal, right? What did we discover? So this is called a hierarchical linear model. And we start out, there's 3 models, model 1, model 2, model 3, and each of them has different parameters. So in the first model, it's the simplest. We just said, okay, if I'm going to model sickness, does the task matter? And we got significance, statistical significance. The task really matters. So the task affects you. And then we said, okay, we got tasks. Now let's add these other things. Let's add gender. And then these are called the big 5 personality scales. So, I don't know, do people talk about Myers-Briggs here? Maybe not. Okay, Myers-Briggs is a personality thing. This is the big 5 personality thing. This is the good one. And so people can be introverted or extroverted. They can be agreeable or not agreeable, right? These are like personality factors. So we said maybe your personality matters. What about motion sickness history? Maybe that matters. Turned out that really does matter. So that's a big predictor, the history. The personality doesn't really matter. Okay? And then we added a last one about how much VR have you done before? That didn't really matter how much VR experience you had. But the workload does matter. So if you are perceiving that two-back task as high workload, then that matters. And then duration. That's a small number, but it's significant. But it's hard to know whether to pay attention to small numbers even when they're significant. So in models like this, you talk about how much variance in the people did I account for with my model. We accounted for a little over 50%, which is pretty good as models go in human factors world, because humans vary so much. And then here's workload. So we've got the control, the 0 back, the 2 back, and then we've got what people thought was workload. And this is the NASA TLX. Some of you recognize that from yesterday. And so women and men are pretty much the same. Everybody thought 2 back was higher workload. So that's fine. That's fine. This is sort of validating the fact that we intended it to be higher workload, and it was. But here's a little interesting difference in men and women. This is now cyber sickness change, or delta, the delta in the cyber sickness. We survey them at the beginning of the study and at the end of the study, and we say, how much did they change in their sickness ratings? And so before and after, not much difference here. Before and after, some more difference here, but men and women aren't different. And in the 2 back, women had a much bigger difference. So this is the sort of thing where you start wondering why. What is it? Is it the other correlation? I talked about the intrapupillary distance, right, as a problem. The other problem is that we know that video game experience can help decrease sickness because you're spending a lot of time in the video game, so your brain is used to some weird perspectives and visual change. Well, on the stats about video gaming, if you say, do women and men play video games? In the US, at least, there are equal numbers of gamers, of men and women. But then you're like, that doesn't seem right because I see all the men gaming. What's the deal with that? Well, you look into the type of game they're using. So the women are doing more like Candy Crush and mobile games, but the men are doing the first-person shooter games and the 3D games. And so it could be that this men-women difference is about gaming experience. So it's not a genetic thing. It could just be about how much they're gaming. And part of the reason I'm telling you this is so that when you read other studies, I want you to be asking questions about, yeah, but the authors claim this. Is that really true? Right? So I'm hoping to give you the ability to ask these questions and not be so confident and not just believe everything they're writing. Right? Okay, any thoughts on this before we go on? Yeah.
I have a question, how does one study the variance in the controlled environment when it comes to the sequence of tasks? Because if they do just the control first and then they do the 0 take and then the second.
Yeah.
Does it matter? They have they already have something to refer back to, so that makes their study. Or did you also try making them do the 2 take first and then later?
That's a great question. So this is called within subjects or between subjects. So within subjects is every subject does all 3 tasks. Between subjects is I come in the door and I just do 2 back. You come in the door and you do 0 back. He comes in the door and he just does control. So with cyber sickness, you pretty much have to do that second method. Because if I had you do the task 1 in a row, the first one's going to make you sick and it's going to affect the second one, like you said. Yeah. So that means you need more participants. One of the students I worked with just finished a study with 400 participants, which is huge in human factors land. I mean, it's a lot of people. She took like 5 months, all these people coming.
Making the same person do different tasks on different days or something?
Yes, you could do that on different days. That's right. The recovery differs too. So some people take off the headset and they're like, okay, I'm good now. Other people take off the headset and they feel bad for like 8 hours. And so the companies like Meta and Google worry about this because if I'm feeling off, I may drive my car into a tree or something, right? And then I'm going to sue them. So it really differs. The hardest thing about running studies like that is purely getting people to show up again. So if I say, you're going to come 3 times, typically we say, you're going to come 3 times. I'm going to pay you $10, $10, and $50 on the last time. And then maybe they'll come. But you still lose like 1/3 of the people. Yeah.
Between men and women because of the difference of different preferences.
Like the preferences of whether they like the corn maze? That's interesting. If they are sitting there hating their life, like I hated that I showed up at this experiment and they're sad, I can imagine that might affect something. I don't have good data on that. You know, as opposed to like, oh, this is cool, it's like a game, you know, if you're pumped up. Huh. Yeah, I don't know, good question. I don't know if it would affect that. Yeah. Okay, so this big picture, we step back now. This is about individual differences. So we've shown that people have different approaches. And so even if you don't care about cyber sickness, you might care about differences that your users have when they're going to use your products. There's a phrase, universal design. Is this a term people have heard? Okay. So I want the product to be good for everybody. And it's actually hard. It sounds nice. You're like, oh, my product is good for everybody. It's equality and justice and all this. But it makes product really hard to design. It's like a pain in the neck. I'd rather say, oh, my product is for males who are below 30, and they're going to be more similar, right? You know, and you're like, no, please. Yeah. So I think as I've been learning more about India here, India is a great place to think about this with all the different cultures in the different regions of India, right? And there are people with different languages and different habits. So if you have a person with a disability, there's basically 3 things you can do. You know, you can get the person assistive tech, right? So if I'm blind, maybe you give me the stick and I'm going to have the stick in front of me. Or if you can change the world so that in the US now, they start, every time you are on a sidewalk, like the roads will have sidewalks, and then when you get to an intersection, there's always a ramp down to the road. And this was originally for wheelchairs, people in wheelchairs. And it turned out it was really valuable for all sorts of other people too, like mothers with strollers and for people pushing their groceries in their grocery cart, you know, down the street. Yeah, and there's this sort of bridge. So here's a brief video. Let's see if we can get this to go, which I think is a nice, powerful thing.
Accessible design is important.
Oh, wait a minute.
Accessible design is important. But is it the same as inclusive design? In this video, we'll tease apart the difference between these two. Web accessibility is defined by the World Wide Web Consortium as websites, tools, and technologies which are designed and developed so that people with disabilities can use them. This means that people with disabilities can equally perceive, understand, navigate, interact with, and contribute to the web without barriers. Now, UX accessibility is absolutely not limited to web design, but UX accessibility means that any user experience, including physical, digital, service design, can be experienced by people of all abilities. It's also not limited just to people with lifelong disabilities. Tech accessibility means a design can be used by people of all abilities. So, acknowledging that everyone has limits to their abilities, and those limits can change at any time. One great example of accessible design is closed captioning. While it might have been created with the deaf or hard of hearing communities in mind, its benefits also extend to people with temporary disabilities, like ear infections, and situational disabilities, like being in a loud or quiet location where audio can't be heard or played. So, accessibility is a goal, a destination. Inclusive design is how we get to that destination. So in comparison to accessible design, inclusive design is a series of design methodologies that focuses on 2 things. 1, understanding, and 2, enabling people of all backgrounds and abilities. This also includes accessibility, but it covers a broad spectrum of differences as well, like age, culture, economic status, education, geographic location, language, among many others. An inclusive design, as a noun, is one that accounts for all of these differences. How do you understand people of all backgrounds and abilities? Well, there's no one way to do it, but I can tell you this: it's not by perspective taking. Perspective taking, or imagining yourself in someone else's shoes, is a mental exercise fraught with bias. Because when you imagine yourself in someone else's shoes, you're still yourself, with all of your own past experiences, expectations, hopes, dreams, envisioning what you might do if placed in different circumstances. And to quote one of our UX mantras, you are not the user. Instead of perspective taking, opt for perspective getting, which is actually talking to and observing people who are currently excluded or who might differ from your typical user base. After all, there might be a very good reason they aren't typical users, like social pressures, familial concerns, or societal and systemic issues. But you can't uncover these reasons with imagination. You uncover them with data. Learn from the people who are the experts of their own lives. Use qualitative research methods to build a deeper understanding of the audience that you'd like to serve. While it might feel overwhelming, the best place to start is by identifying who might be excluded or who might have a hard time accessing or using your services. As for how you might enable people of all backgrounds and abilities, remember that inclusive design is about that, enablement. It's not about creating a single design that is perfect in all ways. It's about creating many ways for people to engage, to equally perceive, understand, navigate, interact with, and contribute. And sometimes meeting very different user needs means having more than one design. At the end of the day, everyone is unique. And while it's not feasible to create an individually tailored design for every single person in the world, any step we can take to make designs usable for a new group of people means gaining new customers. A win for underserved communities, a win for businesses, a win for all.
Thanks for watching. If you want to see more of our UX videos, click.
Okay. So this is interesting, right? And she's saying so strongly, it's not perspective taking, because for about 5 years in the UX industry, everyone was about perspective taking. And you've heard about empathy sometimes. Empathy is a buzzword. And now empathy is getting a little more like, no. You can't really have empathy of somebody if you don't know them or understand them. You need to spend time with them. And this gets to things like you might decide, like when we were building, I talked about yesterday, we were building this software for the traffic managers. And we would go and spend time with the traffic managers and watch them, sometimes 6-8 hours a day. We're watching them and listening to them talk. So you've got to really know your person. Another story on this is I have a colleague who is Chinese, but she lives in the US and she works for Airbnb China. Is there Airbnb here? Yeah, okay. So she was responsible. There's a special part of the mobile interface for Airbnb that if you are a power landlord, like you have 20 properties and you're renting all these different properties, and they've got a whole different user interface for you. And she said, first I designed it for the American users, and then they said, oh, go design it for the Chinese users, but don't spend too much time on that. Just use Google Translate. And she said, yeah, you're shaking your head. And she showed us, she came to my class once on Zoom, and she showed us how terrible this was. Because you just do Google Translate, and like Chinese people think about names really differently. And she would talk about, oh, you Americans with so many letters, it takes you so long to write things. My name is just 2 characters, not a whole bunch of characters. And they think about dates differently. And so when you do Google Translate, it's just changing the fields, leaving them there, but changing the titles, and it was a mess. So then she would talk about Chinese users being confused. So you have to understand the culture, understand the users. Okay. So let's go back to this. So physical disabilities, there's some lingo, and I don't know, this lingo may not apply in India, right? This is the lingo the US uses. I've got some health condition, maybe I have Parkinson's disease, and so I have a tremor, right? It's hard for me to use phones because my finger's moving, I'm trying to tap. So we've got an impairment. That's like the medical stuff. We've got a disability, and we've got a handicap. And how are these different? So cerebral palsy is another disease of your muscles that makes you can't move. So the impairment is I can't control my muscles. That's just the medical fact. The disability is I have trouble using my mouse or using a phone and tapping. And what that means is the handicap is in my life. That's sort of my life implications, is I'm going to have a hard time getting a job. I'm going to have a hard time even applying for a job. Yeah. So here's some things that typically happen. For example, with keyboards, if you don't control your muscles as well with your fingers, you can end up with, well, I pressed the key too long. And you probably know if you hold a key down, it starts repeating. So then you'll see people like, it's repeating, I didn't want that. Or their hand is moving this way, so they press several keys. They wanted to press one key. They're missing keys, bouncing. So this is the higher frequency stuff up top, lower frequency. So what's nice is that somebody has analyzed this for you, right? And then you can take advantage of this. And so in your app, you might decide, there might be people with muscular diseases using my app. I'm going to make my buttons really large. I'm going to make there be more space between my buttons, so it's harder to press the wrong button, right? Here's some mouse issues. Double clicking is really hard if you don't have good muscles, and people sometimes have violent opinions about the double click speed. Like, don't change my double click speed. This is what I like. What you'll see with people who have motor control problems is they want to click on this file and open this file, but their mouse is like moving all around the file. And then dragging is really hard, right? I'm going to drag a file to a new folder, and on Windows, the folder icons are tiny. So, here are some of this is again age. This is the depressing age graph. So we're going from age 45 to 75 plus. Percentage of the population on the y-axis. So as people get into their 60s, a lot of them are going to have arthritis. So their hands are not going to be as flexible. The visual is down here. So we've got visual disabilities. It's not as bad. People often get their eyes, they might have macular degeneration. They might have to have some eye surgeries, but eyes are often okay. Hearing gets worse though too, right? This is US data. Yeah, good point. You might be interested to know, we have red, green, and blue cones in our eyes, and dogs only have 2 cones. I forget which 2 they have. I think it might be red and green. I don't. But the dogs don't see the same colors as we do, right? And there is this amazing creature in the ocean called the mantis shrimp that has 16 cones, and when you look at a mantis shrimp, you're like, oh, it looks like a psychedelic rainbow. So if color is often about mating, and so you can imagine like, oh, I want to remember this shrimp, and I need to have 16 cones to remember that. But blue gets harder as you get older. We start out when we're born, we have fewer blue cones, and then if the cones are sort of dying off a little bit as you get older, then if you lose some blues, you're losing more functionality. Glare gets harder. You might hear, at least I don't know if it happens here. I hear my parents and will talk about things like, oh, when I'm driving at night, the headlights from the cars coming towards me are really bright. Like it looks like a big starburst. It used to just look like a white circle, but now it looks like psh. So people's eyes adjust, and that's harder to see. Auditory here. So do people use smoke alarms here? Where there's like a little gadget on your ceiling and it detects smoke and it goes like a beep. Oh yeah, see there's one right there. So beeps, high frequency beeps are famous for you not knowing where it's coming from. So if we've got 2 alarms in here, and if one of them beeps, we would probably have a hard time figuring out which one it is. We'd be like, okay, I'm gonna stand here, wait for it to beep, and I'm gonna go over here, wait for it to beep. Because their high frequencies is, it's a lot of waves hitting, and it doesn't work well with our 2 ears and doing location distance. So it gets even harder when you're older. And you'll find if you are speaking to an older population, you want to talk more slowly, right? And it's not that they're dumb. This is what's hard. Because I've seen people speak up to older people and like, so everybody, we're going to go out and do some fun activities now. And it sounds like they're children, right? And you're like, no, don't do that. You just need to talk more slowly. They're still smart. Yeah. The motor skills, I talked about the arthritis. Double clicks. Okay. So there are things you can do as a designer, like higher contrast, right? I don't want to see like blocks that are gray with black text on them. If it's the gray block, I want to see white text, right? That's going to have contrast. The amount of visual search. So I have to look all over the screen, Some of you have seen the ways different software has delete buttons. So if there's a powerful high consequence feature, it might have the delete button in big red ink, that sort of thing. It'll have a confirmation. Do you really want to delete like that? So you need to do some things like that. So children, what about the children? What do you do for them? Turns out they have lower motor dexterity too. Sometimes you need more repetition. You have to worry about child safety if you're taking their data and there's a chance some stalker is going to be online. And there's a lot of controversy in the US about if it's okay to have kids have screens at all, right? I think the current US pediatrician, like the Doctors Association, says no screens before they're 2 years old. And then we recommend no screens until they're like 10 years old. And a lot of parents are like, well, that's dumb, but people are doing studies to see how it's affecting folks. Because the companies are all out there trying to get your eyes more on the phone, right? Okay, how are we doing? You have a question, yeah?
So this thing about this talking about no screen for 2 years at least or even 10 years.
Yeah.
Now, in India, some people believe that if a child is exposed to a mobile phone early in life, he would pick up those things so fast that he would become much better later when he grows up in handling such. Is that correct?
So I wouldn't believe that necessarily because the phones are so easy to use. I don't think we need to train them early. Like if you give a 10-year-old a phone who's never seen a phone, they're like, I'll learn it. And in 5 minutes, they're good. So I don't think it's like a skill like soccer or something or football, right? Or cricket that you wouldn't want to learn from early on.
Look at us, we started using phones much later than we are doing right now.
Yeah.
And Australia, in fact, banned using screens for children.
Sorry, say again?
I think Australia banned personal phones for children already.
Yeah, right. And there's the worry that most people have is about attention span. So, the phone responds to you immediately, pretty much, or maybe not immediately, a little bit of delay if there's some network lag, but it's going to respond to you. And you are always in control. So in real life, how often are you in control? Like, not that often, right? And how often do things happen immediately? It's like, not that often. Sometimes, if I trip and fall on the ground, I get an immediate pain, right? So some of that. But life is not really immediate and with you in control. So really you need to, have more training and walking around and having your skin knee, you fall and you have a skin knee and you pick up and you say, I'm fine. I feel like there's more training to do that. That's just my opinion though. But I think a lot of the studies are worried about attentional span going down.
I guess like for a long time, as long as the phone was being used as a tool, things were going fine. But now that the content is being designed to decrease our attention span, and now with the AI, and there was a recent MIT study which said that it's really messing up with our brains.
Yeah, it's going to be hard. I feel like the phone use and the AI use too is a little bit like saying, I've got a free buffet for you with all the food you'd ever want. And you can just have as much food as you want. And by the way, you should try to eat only the healthy food. But, all the food is there. And you're like, oh, I don't have time for healthy food today. I'm going to grab this fried thing, something like that. So with the AI, it's like that. It's all the features are there. And in an MIT study and others will say, you should only use it for these purposes. But you're like, oh, but it's so easy to use for the other purposes. So it takes a lot more self-control. And humans don't have a good history of self-control. Yeah.
Babies, till they grow for like around 6 to 7 months, they're not able to see all the colors. That's what medical side they say. You had mentioned about that optical flow. How is it usually measured?
The optical flow. So if you're measuring optical flow, usually you get like 2 frames of a video. Maybe here's frame 1 and frame 2, and you map the pixels on and then subtract the difference. So if between frame 1 and frame 2, 10% of the pixels moved, and you're like, it's got an optic flow of about 10%, as opposed to all the pixels moved, and it's like, it's like 95%. Something. It's like things like that, like little vectors.
Today's reading that you had given about empathy, there was something about slipperiness of empathy.
Yeah, it's slipperiness of empathy, yeah.
I didn't get it. It said this is all heavy stuff that you've given us because we would probably have to read it again and again.
Yeah.
So this thing that you mentioned about inclusive design, where they were talking about perspective rating, but now where do we draw the line and say that too much? I don't know if it's about too much empathy and which affecting the whole design.
Yeah, so for a while, everybody was talking about empathy. You have to understand your customer and their needs. What are your customers? Oh, my customer is a middle-aged mom who is really stressed because she has 4 kids and she's running around, something like that. So you understand the mom, but you are not a middle-aged mom, like most of you, right? So that's the empathy has been getting the pushback. So people were like, oh, I'm going to imagine being a middle-aged mom. And it's like, well, you can't really do that very well. You can't, I mean, you're just not going to imagine all the things. And so it's much better to find 10 middle-aged moms and interview them and follow them around like a shadow for a couple hours. And then you're like, now I understand middle-aged moms. So that's the perspective giving part. Like you're actually getting the data from them. And so I'm trying to remember to link this back. You asked about something. Oh yeah, so that was the empathy. So the article I put in the folder was about empathy getting sort of pushback. So for a while it was empathy, and now it's like, nah, not so much. Yeah. So is that helpful?
If I may ask,
yeah.
You mentioned that bottom up and top down influence on perception. How do we understand that?
Top down, bottom up. So this is interesting. You have a retina in the back of your eye, right? The retina's there. It's got all the little like receptors. And the wires from that retina go to the back of your brain, like back here, is all the part of your brain processing vision. And there's I think it's about 50,000 neurons going back. So there's a lot of wires. But there's even more wires going to your eye. Okay, and you're like, what? Because why do I need to go to my eye? My eye is a sensor. It's like a camera. It's like, well, no, it's not. It's being tuned. And so if you are panicked that there's a tiger over here, and you are really looking for tigers, then all the features of your eye that are tuned to stripes and like movement in the shadows are going to be highlighted. And so and from those wires going to your eye, it signals about like, pay attention to this, filter this way. So our sensors are actually really tuned by our goals, which is a little startling. I mean, we don't fully understand it yet. We just know that there's these tuning systems. So we're not just like a camera, right? Does that help? So the top down, I guess that's the answer. That's the top down. The top down was like, I need to watch out for tigers. And then the bottom up is like, oh, I see this pixel, I see this pixel, I see this pixel, and I see, green and orange, and what do I make of all those? So the bottom up is like, oh, I see some orange, and it looks like they're in continuous movement, so that maybe that's a stripe, and you're sort of working your way up. As opposed to at the top, you're like, I want to look for tiger. And then you're going to break that down. Yeah. Okay, this is a video I wanted to play of somebody who's blind, who's using a phone. Has anyone known or seen somebody blind using a phone? Okay, so I think it's fascinating. We had a blind graduate student getting his master's in HCI. And in this video, she's got the phone turned on to show us what she's doing. But if you're blind, you don't need the screen, right? So the screen is off, and you have really great battery life. And the other thing that they'll do, you'll hear it talk really fast. And do they have in India here these TV commercials for drugs? And then at the end of the commercial, it's like, and you may die, or you may have all these side effects. So in the US, it's like, this could enable you to have no more arthritis. And it's like, but some specification they apply, and you may die, and you may have constipation, and you may, and it goes through. So our brains can hear faster than normal people can talk. Okay, so the blind people have realized that, and they'll often have the voice at 3x. Like you and I will get lost at 3x unless you practice, but they're practiced, right? So let's watch this.
Hi, I'm Christy. I'm just showing a little video of how a blind person would use an iPhone. So basically, you go to,
can you hear this?
You run your finger along the screen and you find what you're looking for. And there's like a little bit of a vibration, so it helps too. And it reads everything on the screen as you're going. And so then I open Twitter.
It's talking to her as she's doing this.
I'm at the top of the Twitter page now. And I'm gonna compose a tweet. And normally you would use the regular keyboard here, but the iPhone also has this other keyboard where when you turn it, it's now I can braille and use a braille keyboard.
So this is like typing Braille.
And so then I can read what I wrote. So I could share that if I want. But that's pretty much the idea. And so
Okay, I'll stop now for here. But it's interesting to think about all the technology that Apple and Google and Android created for people like this. Right? There's all these hidden features in your phone that most of us don't play with. And in one class I had, we spent about 30 minutes turning on the voiceover and exploring it. And generally students responded like, I don't know how to do this. This is really confusing, you know, because you have to practice it. In the US, there's accessibility laws. There's this government accessibility law that says everybody has to be able to do everything, no matter what their ability, which means you have, if there's ever a building with stairs, there's a ramp for a wheelchair. So it costs more, you know, because you have to build extra stuff. But it does mean that the Android and the Apple OS system have a lot of these features built in, which is nice. I don't know if, you know, a Huawei phone does the same thing or not. But, so I'm going to move ahead. For JAWS is, it's going to talk you through a web page. So it's software that's free and you can install on your computer. And then when you bring up a web page like NewYorkTimes.com or somebody will be like, NewYorkTimes.com. And then you're like, first headline, and it tells you the headline. So here's some other situations besides blindness.
Okay, sir. Thank you, sir. Thank you, ma'am. Okay.
To get past this.
Web accessibility perspectives. Video captions. Video isn't just about pictures. It's also about sound. Without the audio, you'd have to guess what this film is about. Frustrating, isn't it? Not knowing what's going on. That's the situation for everyone who can't hear. Captions make videos accessible, which is also handy for people who want to watch video in loud environments, or where you need to be very, very quiet.
Can you hear that the guy has a British accent? Is that obvious to you? Or not so much?
Colors
Okay.
with good contrast. There's something about great design that allows it to go practically unnoticed. But it doesn't take much to make things confusing and frustrating. Choosing colors with poor contrast makes navigating, reading, and interacting a real pain. Good design means sufficient contrast between foreground and background colors. That's not just text and images, but links, icons, and buttons. If it's important enough to be seen, then it needs to be clear. And this is essential for people with low contrast sensitivity, which becomes more common as we age. With good colors, websites and applications can be easier to use in more situations, like in different lighting conditions. Voice recognition. Imagine if you could only communicate with your family by writing. Sometimes it's just easier to speak. One of the advances of technology is voice recognition, whether it's searching the web,
19th century architecture,
dictating emails,
Send email to Jack Hard,
or controlling your navigation app. Many people with physical disabilities rely on voice recognition to use the computer.
place order,
But for that to happen, websites and apps need to be properly coded.
go, cancel,
Voice recognition can help lots of other people with temporary limitations too, like an injured arm.
Place order.
It can also prevent injuries becoming worse, like RSI, repetitive stress injury, or for people simply preferring voice.
Text to speech.
Some people can see the text on the screen.
Fortunately, computers can convert text to speech.
It's technology that many people who are blind have been relying on for years. But it's also important for many people with dyslexia, and very useful for people with difficulty reading text, as well as some people who just like to multitask. But for this to work, websites and apps have to be properly coded, which has the added benefit of helping search engines index websites' contents better. Clear layout and design. Poor layout can be very frustrating. And the same applies to the web. Good design involves good layout, and that means a better user experience. This includes clear headings, navigation bars, and consistent styling. Any web user will get frustrated with bad layout and design. Complex layouts also make finding information difficult or impossible for people with visual disabilities. And they are confusing for people with cognitive and learning disabilities who need clarity and consistency of the presentation. Bad design also impacts anyone who isn't particularly confident around computers. Notifications and feedback. All the right gears can be put in motion. The hands can be at the exact place they need to be. But if you don't get the response that you're expecting, you'll end up wondering if there's some sort of problem. It's the same on the web. Without clear notifications and feedback, people are quickly disoriented and confused. Especially error messages, which are often complex and confusing. Yet making them understandable is usually quite simple. Making websites and apps predictable and understandable makes them accessible to people with cognitive and learning disabilities. And more usable for everyone, especially for people with lower computer skills. Large links, buttons, and controls. Trying to hit a small target requires lots of effort. Many websites and applications try to thread the needle. But on the web, we can make areas for clicking and tapping larger and easier to use, which is handy on mobile devices, especially when we might be moving around at the time, which is critical for people with reduced dexterity.
Customizable text. What's right for you doesn't necessarily work for the next person. Customization isn't always just a question of preference, though. Sometimes it's a necessity. Being able to adjust the text is crucial for people with low vision and dyslexia. Properly coded websites and applications allow the text to be customized. For example, to change its size, spacing, font, and colors without loss of functions or clarity. Understandable content. Instead of saying, to postulate a conceit more irksome than being addressed in sesquipedaling syntax is adamantine, it is better to say, being spoken to in unnecessarily long and complicated language is a pain. Yet many websites lack structuring, using headings, lists, and separation. Or they use overly complex language, jargon, and unexplained acronyms. It makes them difficult and unappealing to use for many people, including non-native speakers, and makes them unusable for people with cognitive and learning disabilities.
Keyboard compatibility. Not being able to use your computer because your mouse doesn't work is frustrating. Many people use only the keyboard to navigate websites, either through preference or circumstance. Whether it's temporarily limited mobility, a permanent physical disability, or simply a broken mouse, the result is the same. Websites and apps need to be operable by keyboard. Web accessibility, essential for some, useful for all. Visit w3.org/WAI.
Okay. So there's a lot of information But I hope your impression is like, wow, there's more than I realized to think about. There's also these websites, the W3C website. It's a US website, but it goes through all the things you can do, in great detail. And then there's website checkers. So you can say, hey, I built a website. How am I doing on accessibility? And you run it through their checker, and it'll say, like, oh, you need to add word text on the images for people who can't see and describing the images. You need to add this. You need to add that. So, yeah. So I think we're getting close to the end here. I just thought, this is a guy from Texas that I knew. He came to Iowa State. He had a friend who had one arm, and he wanted his friend with one arm to be able to play the shooter video games that his son really liked. So this kid would come over and play with his son, but the kid couldn't play the video games. So he made this glider thing, and so you put your feet on it, and it's like pedals, but then there's also these little switches, so I can put my foot here and then lean in the foot. So if I lean in the foot, it's another mode, because it'll go like click. And so you can like navigate, like go forward, backwards, pivot, turn, shoot. So this kid now with one arm can do everything that the buddy can do because of this foot pedal thing. And he was trying to sell it on Kickstarter, that sort of thing. WCAG, that's the web stuff we talked about. There's mobile, and there's what Iowa State does, but yeah. Okay, time for break. Thank you. I hope that's a little exposure and a reminder to do digital accessibility. Okay. This is now break for how long? What are we, 15 minutes, something like that? All right, so my goal is to stop at 12:15. I think, is that right? Does that sound right? 12:15? Okay. All right, let's talk about culture and society. So there's a professor named Murdu Kashyap, whom I really like. I met her like 30 years ago in Chicago, and she and I have worked closely off and on throughout the years. So she still lives in Chicago, and she teaches for Iowa State online. And she's got about 30 years of experience at Motorola and Allstate and corporations. So she brings those stories to the courses. So she talks about these levels of socio-cultural research. So most of the time when we're thinking about UX, we're down here. We're like, oh, I have a user who's confused. We need to have better affordances. You know, how do I open this water bottle quickly? Okay, I've got 2 steps. I got to flip this down. I got to punch this. So maybe I'm frustrated by that, depending on what I'm doing. Or maybe I'm happy because it's more secure. And that's down in here. This is about people and affordances and interactions. But this next level is about community. So it seems like a lot of people in India use WhatsApp, right? Well, it wouldn't be so effective if everybody didn't use WhatsApp. So like once everybody's in, then it's like, oh, we've got a whole way to communicate now. This is great. So you can build a community around WhatsApp, and then it enables you to communicate with groups and with vendors. You can ask customer support. You can do all sorts of things. So this is groups of humans that have common goals, basically. And then up in culture is even higher level. So some examples of culture might be things like, in the US, there's a typical like individualistic culture. Like people are out for themselves often, like I want to get rich and do for myself. You find other people are not like that, but I think that's a little more the stereotype is I'm out for myself. Whereas maybe that's not true in other countries, right? In Sweden and Norway and the Scandinavian countries, they're more like communal. And they're more like, oh yeah, you should have time off when you have a child. You should have a year off because that's going to support you and our whole community will support you. So you end up with these sort of higher rules. And what's nice when you're designing products is you can check in on each of these layers and say, okay, my new product, how is it going to affect this level, this level, this level? So it might be that we've got some affordances down here. This is about relationships and social things. So WhatsApp has made decisions about, can you see when people have read messages? Or, do we give you the option to turn that off? Do you give it the option to download everything or not? And those are all things that affect socializing and relationships. And there are also things like, up in the culture level, there are things like, oh, let's have laws that mean that people with certain religions have a harder time living here. Or people, if they're do people say LGBTQ here? I don't know, queer, something. Okay, so there's different laws about that in different countries, right? And so that's going to affect your technology as well. So this is one of the articles, the Peters article. And what's interesting is you get people with tech-centric views and human-centric views. So let's look. The tech-centric view is going to be somebody like Elon Musk, like humans are scum. The technology rules, we need to take over the technology. And that's a little bit of a stereotype, but it's like, okay, yeah, the AI is going to take over, it's going to be great. And then the human-centric view is a little more like, okay, humans are always superior to AI because they have social aspects, they have feelings, they can understand the impact of nature. Director Rao yesterday was talking about, it's Rao, right? I got his name right? Yeah, he was talking about the impact of nature, right, and the complexity. So this is the human-centric view. So if your users are one or the other, that might affect you. If I'm tech-centric, I might roll out a new product and say, well, everybody's going to buy this because it's awesome. It's the newest tech. And half the people are like, I don't want the newest tech. It's going to break. It's sort of scary. This AI is frightening me. So you need to understand where you're coming from. Then there's this other view, collective intelligence. It's a little bit like we're going to work together, the humans and the AI. Right? We can work together if we figure out how to do it right. So let's look at some examples. There's this term superintelligence. Yeah, sorry.
I just had a question because when you started talking about human-centered design, there was this parallel going on about planet-centered design.
Oh, yeah.
So, do we have something similar
Yeah, that would be at the top level for sure. The planet-centered, exactly. And I've heard about sustainable design, right? You know, so whenever you type in ChatGPT, it's using water. So people have talked about, you know, a bottle of water this big is about 50 prompts, something like that. So is that okay? No.
It's extremely energy extensive.
Right.
So I think it's much more than, like, just for one prompt, it's much more than a bottle of water.
I mean, it could differ depending on the prompt or something. Somebody was telling me like bottle, I think they were telling like the bottle you've got, the plastic one, was about 50 prompts, but it could differ, right? And it could differ as the machine learning system gets smarter. You know. But it's definitely a consideration, yeah. Superintelligence is this idea that the computers are going to be smarter than humankind eventually. And the human-centric view sees the threat as, oh, humankind's social nature is going to be overlooked. We're all going to be on our phones alone in our houses and not talk to each other. And where's the social, you know, aspect? And then there's this collective view. What's interesting on the once you get up to this top level, it's easy to create things that are a large, complex system, and you're not really sure how to take it apart. So when I went, did I mention I lived in Namibia for a year? I forget if I told you this. Okay, so my family went in 2022 for the year of 2022 and lived in Namibia, which is down by southern Africa. And I had a former student there who got her PhD at Iowa State, and then she was back in Namibia, and she's like, hey, you should come visit. So we went on a Fulbright scholarship. Do y'all know about Fulbright? So it's a US scholarship that I haven't looked at so what I would want to do is look at the US Embassy in India under educational opportunities and see if there's Fulbright, and they might say something like, we'll send you to the US for a master's degree.
I think in India it's Nehru Fulbright.
It's the which?
Nehru Fulbright. So Nehru was like, he's Indian and he was Prime Minister. Yeah, so with Fulbright, they have kind of collaborated for Indians.
Okay. But there's an opportunity to come to the US maybe with Fulbright. Well, I'll look at that later. So my wife and I got a Fulbright. You can also be a professor and get a Fulbright. She's a professor too. And so she got the Fulbright to go to Namibia. So we were both visiting professors there. And we learned a lot from that experience. Because I feel like here's an example. There was a kid so we took my two sons who are teenagers, and they're getting to know friends at school. And there was one kid who had just started computer science at the University of Namibia. And I said, oh, hey, Vander, what are you learning in computer science? He said, oh, we're learning Java. I'm like, okay, great. I was like, are they going to teach you Python at all? And he's like, what's Python? So it was astonishing to me that a 19-year-old in computer science could not have heard of Python. And I'm like, why is this? How did this come to pass? And I think what it is because there's one telecom company pretty much in Namibia that provides all the internet and the cell phones. And they are tight in bed with the government. So they give all the taxes to the government, which means their internet rate is the most expensive in all of Africa. So the internet is too expensive to browse at home. So the kids at Namibia will browse at work or at school, but nobody's really like watching YouTube at home because it's too expensive. And so this is an interesting little effect where the media, the comm company is just like, oh, we're going to charge this money, not realizing that they have this ripple effect on the whole culture of the country of like not letting people learn vicariously. And so when Joanne, my spouse, and I were living in Namibia, we're like, wow, there's a couple different big problems here. And it's like a ball of yarn that's all like pushed together, and you're like, where do I pull first? If I want to undo this knot. And it's really unclear. So when you get to that top level, that's when there's a lot of things interacting, and it's not really clear how to solve it, right? I don't know. So I'm not saying it's hopeless, right? But you got to try sometimes. But that's the systemic problems. So let's look a little at the micro. We've got some humans, and we've got some AI, and we've got some activity that they're going to maybe do together, right? And if we're collective, we're ideally going to collaborate nicely and do this activity together. And so there's this phrase about AI, that AI is good for doing dull, dangerous, dirty, and difficult things, the 4 Ds. And so, AI could do dull things like count the number of people in this, age bracket or something, or dangerous things like go rescue this thing that's near dangerous chemicals. dirty or just difficult stuff. So, but humans are up there, and they have needs like, hey, I'm a human. I have limited memory. I'm going to forget things. I get tired. Whereas the machines never tire. I have biases. Maybe I am biased to be, I think, I'm human-centric, something like that. And social pressures, too. Your friends can be like, hey, why aren't you using ChatGPT? Everybody's using ChatGPT. And so the tech-centric view, so I'm going to show you the tech-centric view and then the human-centric view. Tech-centric is like, oh, yeah, AI can do anything. And if there's AI brings up new problems, we can solve it with AI. We're good. And it's going to get just better and better for the humans. And we've only hit a fraction of the potential. We are just at the very birth point of AI. Look, it's going to grow so much. Okay, here's the human-centric view. But no, this is still tech-centric. Have people heard of general intelligence, artificial general intelligence, AGI? This is the idea that like the AI now is, usually somewhat narrow. When it started, it was pretty narrow. Like I'm going to diagnose cancer in X-rays, and then we get narrow superintelligence like ChatGPT, where it has scanned the entire internet, and now it can talk about a lot of things. But it's not general intelligence because I can't say things to it as well about human relationships. I can't really trust it. It's not like another friend. But the tech view is like humans are biased. We need to get the human biases gone. So the human-centric view is more like this. I'm going to try to automate labor. So I don't want to pull weeds out of my garden. I'm going to have the robot do that. That'd be great. I'm going to delegate hard decisions. Which car should I buy? If the AI knows me, it may be just like, here's the car for you. Like that would be nice. That's a big cognitive load. Tasks versus thinking tasks versus feeling tasks, right? So I might have just plain old tasks like take out the garbage, put it somewhere. I might have feeling tasks like my mom is getting older and is starting to slow down. Do I need to talk with her about this and maybe talk about moving her to a care facility? Like this is a hard thing. A lot of people my age are dealing with this with their parents aging. And it's a lot of cognitive load in your brain, right? And it's all emotionally wrapped up. Yeah. So it's unclear that AI could do that for you, right? Or it might tell you like, here's what everybody else is doing. And ideally we have a cooperative team, so I understand what the AI is doing, right? So here's an example. If my stepdad has passed away now, but when he was alive, he had a stroke near the end of his life. And he could understand you fine, but he couldn't produce the words that he always wanted to produce. So you could ask him how the day was, and you had to be very patient to have him get the words out. But when I would introduce people to him, we're walking around with a mental model or schema on how to interact with older people. Here's what you do. You are gracious, you talk slowly, here are the things you do. And we all have mental models for how to interact with a 5-year-old too, or a dog or whatever. So, but when I introduce you to my dad and I say, my dad, had this stroke and he can understand you fine, but he can't always find his words. You easily adjust. You can adjust your mental model and be like, oh, cool, I'll just be more patient. That's fine. And you can interact with my dad. But now let's think about like Alexa or Siri, right? Alexa maybe, let's say it has 5,000 things it can do. And then you're like, okay, I'm getting used to Alexa. I know I can ask it to play my music or do this or do that, and I can ask it these things. And then it gets a software upgrade. And now it can do 5,000 new things. It's like, how are you going to deal with that? And nobody's figured out in the companies on how to deal with that. Like, I need to convey to you, this person has new skills, right? Yeah. And it's easy to increase those pretty dramatically. I don't know, do people do karate and taekwondo here and that sort of thing? And you have these colorful belts, right? And so if people are in that field, they're like, oh, he's got a green belt. That means he can do this and this and this. So it's almost like for the AI agents, we need these belts or badges or something. Yeah. Nobody's really figured that out. You could be the person who labels that and figures that out, right? And publishes and be like, yeah. So in this human-centric view, and we're in the meso level, we're talking about communities, there's a lot of trust in here. And the systems work most, say the authors of this article, systems work best when individuals can act in self-interest and in the interest of others, both. Like it gives you the chance to do both. You can decide if you believe that or not. But so this human-centric view would say, well, hey, AI can only do part of the human. So there's a lot of real-world problems, like how to make water cleaner or how to make their air cleaner. Like AI can't solve that. Sorry. Somebody's like, yes, it can? No, I don't know. So we'll see. Maybe we can in the future. And the humans are going to be like, yeah, the real world's too complex for the AI. And if you got new problems with AI, typically AI can't solve its own problems, and it just causes problems. So you get people worried about this, right? And let's think about HR functions. So do they call it HR here, like human resources? Yeah. So I get hired. Maybe somebody's harassing me at work. I'm really feeling bad. I'm not comfortable at work, coming into work. I'm scared to come into work, and I need to talk to somebody. So, how do I do that? Like, where is that in the human versus AI? That's a sort of a feeling task. Do I want that? If I'm the HR human who's in charge of HR, I probably don't want to delegate that to AI. Maybe there's an AI bot that I can chat at first. I'm like, hey, somebody's harassing me. What do I do? And maybe it has suggestions. But when it comes to decision making about do we fire this person or do we start an inquiry, then I probably want a human involved.
Thinking about this HR question.
Yeah.
For the AI to respond to it, somebody would have been feeding this kind of informational solutions over the years, and then it builds up its database of replies.
Yeah, that's
so
right.
Who decides it's correct that's going inside?
Yeah.
Who edits or?
Yeah, some author of the content gets to decide here's the right behavior with HR, right? And then they're going to upload that to the AI. But it's an interesting question about like who gets the power to author the AI's responses. Have you ever done a poster session where you like have a research poster and people are walking by and you're like, here's my research, So one of the students I work with made an AI avatar to talk about their poster, to give practice for poster sessions for grad students who've never been to a poster session. So she took 2 of her peers and copy pasted the poster content into the AI bot. Of like now, and it comes like ChatGPT, and it knows all general stuff. And then there's a text box where you could add, like, I think here's this other stuff here's this poster content. And so we did that for this student named Yvonne and for a student named Ralph, and then the 2 different avatars could talk eloquently about their posters. So it's not hard to add the knowledge, right? It's sort of startling how good they were. Yeah. So generally, this is try to consider systems at the micro, meso, and macro level. Here's at the very high level about culture. And some people define culture, it's hard to define culture, but you can define it as values plus context plus behaviors. So the behaviors like, what are people doing? Let's think of a cultural example. Since visiting India, I had to learn how to use the sprayer next to the toilet. So now I'm really excited about the sprayer. I'm like, oh, we should have this in the US. This is great. But I had to learn that, right? So there's a behavior about how you use the toilet. And then there's a context about, okay, here's the bathrooms around the place. There's some are public, some are private, some are different circumstances. And there's a value, and you might have a value in like, oh, you need to be clean in the bathroom. How are we going to do that? And so that comes together to a culture of like people building sprayers everywhere. This is the article again, and you may not agree, but the authors of the article talk about what is intelligence. And it's the intelligence of a system is about how the entities are working together. So a more intelligent system has more opportunities for the entities to work together, as opposed to, oh, it can mow your yard or it can pick your weeds, but it can't buy a car for you. And there's this idea that, alone you're going to be less powerful than if you can actually collaborate and be a cooperative system. So my pitch here is sort of think system-wide. And here's a little bit more on the systems. Have people heard of design thinking? Do people talk about design thinking here? Okay. And there's systems, and then there's values underlying the design thinking. So this is a couple slides from the Luma Institute, and I am not getting paid by the Luma Institute. I am not trying to say they're the best one. It's just they have some nice pictures. And this, you may say, oh, this is stuff we've all seen, so I'll be quick. But if I'm going to design for users, I need to get to know my users, right? And I'm going to watch them, I'm going to understand them, try to make them. And all these bullets are techniques, like tools in your toolbox that you can use. How do I watch users? Well, I'm going to interview people, or I'm just going to observe. They all got fly on the wall observing. There's a fly just sitting there. I'm going to shadow them and walk a mile with them. You know, you can ask people to be like, okay, what feature would you buy from the system if you had some money? What extra feature would you like? Can you do some journaling for me about how you use the system? So these are all techniques, and then the understanding as well, and then the making. And you can go on the Luna website and read more about them.
There's something very similar. I think you would probably know already. It's called IDEO method cards.
Oh, the method cards, yes. So you were saying the IDEO method cards? Yeah. Yeah, there's the IDEO method cards, and then there's a professor at Iowa State who made her own deck of cards, and she's like, mine are better than IDEOs, but like hers are not selling like IDEOs, so we don't know. But yeah, there's the. I think this is a little more systematic than like randomly drawing the cards, but the cards are good if you're feeling stuck and you're like, I don't know how to approach this solution. And it's like you draw a card and it's like, oh, maybe think of it from the point of view of a child. And you're like, oh, okay, maybe. Right, that's right. So I'm not saying they're bad, but. So the UX is typically over here in the looking. Most of the UX techniques are over on the looking side. There's a little bit less on the understanding and making, but in the UX world, have you all heard of Agile? Is that a thing people talk about? Agile programming? So not everybody knows this, but back in the day in programming, it used to be like somebody writes the specs, like this software must allow an airplane to take off successfully, you know, and it's got to have these features. And then you write all the features out, and the next people start programming it, and the next people start debugging it, and it's called waterfall. And it's like handoff. And it's extremely expensive, and when things go wrong, you're like, oh, pass it back up the waterfall. And it takes a long time, and it's frustrating. Now, waterfall is still sometimes needed for like life and death systems, like a hospital monitor, or maybe a military something that's going to drop a bomb on somebody, something like. When you're thinking about things where life and death is in the line, then maybe the waterfall is okay. But most software is developed now using Agile, which is this iterative cycle. And typically there's 2-week sprints, and it's a cycle. So it's like, hey, developers, let's get together in a room, and here's a feature I need, and here's another feature I need, and you get this feature to build, and you get this feature to build, and come back in 2 weeks, we're going to see how you're doing. And you come back, and you're like, okay, how's this working? And they say, okay. This is working pretty well on this one, but this one needs fixing. Okay, next sprint, you're going to do this. So it's iterative every 2 weeks, all the time. And a lot of companies will use this. And the UX crowd has been feeling often like, well, that leaves us out. What are we doing? How are we doing UX when people are all vigorously doing these Agile things? So somebody invented something called lean UX. Lean is the term from like Toyota and Japan and being all efficient in your company, you know. So lean UX is like dovetailing with Agile. So you can do Agile and you can do UX as part of the sprint. So if you like this idea, you can read about lean UX. But yeah. Okay.
Anything that you would recommend to understand Agile practically?
Sorry, say again?
Anything that you would recommend to read to understand Agile in a practical.
I think there's a lot on the web about Agile, so you could just Google Agile programming, maybe Wikipedia, that sort of thing. Or maybe medium.com. Do people here read medium.com? It's sort of a website that has a lot of information about UX. So there's going to be some Agile people there. And Agile's a little bit like a religion. Like some companies are like, we do Agile, and we call them sprints, and they're always 2-week sprints, and they're very strict. And other companies are like, we have the spirit of Agile. We are iterative. But we're not going to hold you to this line, you know, because that's just going to make everything painful. So that people vary on how strict they are in their interpretations.
Agile is kind of traditional old way of doing solving the problem. Like modern problem requires
Yeah. Yeah. Have you seen the double diamond? So this is a British thing, and time is moving left to right. And so if I say that's a British thing, does that make you go like, ew, it's a British thing because we don't like Britain? I don't know. I don't know how that works here. Okay. But time is going left to right. And usually you've got to figure out what you're designing. So I have a problem that let's see, birth control pills don't work well for every woman. That's maybe a problem I want to solve. There's different recipes for these different pills, different hormonal levels. And so I decide, what am I going to do? I'm going to do discovery. I'm going to interview a bunch of women who are using these pills. I'm going to define the problem. I'm going to narrow it down and say, okay, here's where the most problem is. Here's where we're going to target. And once I get there, I've defined the problem. So the diamond is there because I'm getting big, lots of brainstorming, lots of information, and then I narrow down to one little problem. And I decide really what I want is a better pill for women in this age range or something like that. And then I have to go and design it. So there's different solutions. Maybe I have different recipes. Maybe I have different factories. I have different things. Instead of a pill, it's going to be things you mix together, something like this. So I have different solutions. I go big and I brainstorm it, and then I narrow down to a product I'm going to really pump out. So this is useful often when you're with a team and you're like, what happens sometimes on design teams is you'll be all over the place. And so then you can tell your friends, hey, remember the double diamond? Where are we? Like, where are we on the double diamond? And they're like, oh, well, we're brainstorming all in here. And you're like, I don't think we really got here yet. Can we go back? Right? And so you can sort of talk through where you are. Okay, so I'm going to skip over these because you can read about them on the Luna website. And Luna has this idea of recipes. So you might take, every one of these methods has like little tiles to them. And then you can combine tiles. You can say, well, let's combine these 3 tiles, or let's combine those 4 tiles. And it's that little recipes. Okay. So the last thing is about systems thinking. We've talked a little about this. Yeah.
Like, how could we elicit latent needs? Like, when we interview, we would know these things, but how do we get the latent needs out?
Oh, the latent needs? So ideally, you're talking to them enough that you start to realize they have needs that they haven't told you explicitly. Like maybe they're telling you about their needs. Oh, I'm always stressed at the end of the day. I wish I had a tool to help me do this before I left. And then what you realize is like, oh, they have no sense of closure of their task. There's no clear finish line for their task. So they didn't tell you that, but you realize that because you spend enough time with them. Does that make sense? It doesn't always work, right? But you do your best to talk to them and start to understand their situation. That does tie into the systems thinking, though, which we're doing. Because if you can somebody will come and say, oh, I'm a cab driver. I drive cabs in Delhi. Here's my life. I do an average of 20 trips every couple hours. And I'm frustrated when I get trips like this and not like this, or I'm frustrated by these things. And you can think about it not just in terms of that user, but as a system. So the system is that there are people who need to move from place to place. There's demand and supply. There are different cost factors. There's people who have trust issues about, do I trust this taxi versus this taxi? So there are all these bigger high-level factors. And you can try to think about it as this sort of systemic thing. And I have this note in here about build a muscle for zooming in and out. So if I spend all day, lifting my water bottle like this, I'm going to build these triceps, right? And I want to build a muscle similarly for zooming in and out of systems. And what I mean by that is like, okay, at the low level of the system, I'm like, oh, this cab driver's needs. I understand the cab driver, I understand his needs. But in the high level, I say, what is good for Delhi? Like, too many cab drivers is more traffic, more exhaust. Maybe I'm thinking at a high level. So like, I'm need to check as I do my design, I need to zoom in and out, right? So I'll be like, okay, I'm doing this design. This is really going to help my user. What's it going to do to Delhi as a city experience? What's it going to do to the ability of the driver to eat during the day? so it's sort of going back and forth. And that's the zooming in and out. So it's helpful to practice that. Here's some examples of systems. This is for, I've got things I've got manufacturing I need to do. Like I've got stuff I need to dig out of the ground, like metals and things. And then I've got systems to serve, like farmers and, we need to make food. So there's this is attempting to put together the conflict between manufacturing and sustainable world, right, in like one diagram, because they tend to be in conflict with each other. And so I've got my user here. I wanted these things built for me. I wanted more water bottles that I can be safe about. But I'm a little sad that I have to throw away a water bottle after I use it. Is there some way I can be safe and reuse it? And so, you get into the regeneration. So it's just trying to map in that. And it's not going to solve your problems for you drawing a system like this, but if you draw a system like this, it can help you with like a mental checklist. Like, okay, I'm designing my product. I got a new water bottle. How does it fit into this? Well, it's really easy to manufacture. Plastic's easy to manufacture. And it's not a huge impact on the environment, but it's some, so you have this sort of checklist. Okay, last thing we're going to do is about values. So Robert Cosma has this book, and I put it in your online folder, and it's a PDF of an entire book. It's like an entire 300-page book, which he made public. It's not like I'm bootlegging it, right? And it's a wonderful book. It's about like making the world a better place. And so he talks about the moral aspects of design. And has anybody ever done a values audit? This is the thing. There's different ways you can do this. You can bring up an iPhone app, a phone app, and it'll say things like, do you think it's more important to be honest or to be genuine? Or something like that. Or do you think it's more important to look good or to save your money? And it gives you all these double choices, these binary choices. And you're like, pick a bunch of choices, it takes 10 or 15 minutes, and then it goes up and it says, okay, these are your top 5 values. And sometimes people find that useful. They're like, oh, I didn't realize I valued this thing so much. I know when Joanne, my spouse, and I were doing marriage counseling, right? We were go to this, we're Christians, so we go to this pastor, and he's like checking us out to make sure we don't screw up our marriage. And so one of the things he did was gave us a questionnaire. And he said, so Stephen, I want you to fill out the entire questionnaire. And then I want you to fill it out how you think Joanne's going to fill it out. And then she does the same thing. She fills it out for me and for her. And then we swap. And if I don't have the guesses for Joanne right, then we got to talk about that, right? That's serious points to talk about. And one of the most interesting questions was the one I like, if your clothes washing machine breaks, do you buy the cheap one to replace it, or do you buy the really high quality one that won't break and it'll last a long time? And because in marriages, the things that screw you up are either money, in-laws, or sex. And so those are all the topics you got to cover. And the money thing can really mess you up. So that was an interesting question, right? And so you get up with these value sort things. You can go through and you can start getting flags about like, wow, I seem to really value saving money. So I hope my partner does too. Or if they don't, we got to talk about that.
A lot of places in employment, they're making such a question as mandatory.
Oh, really? For the employers now?
Yeah.
They want to know your values before they hire you?
I think it's got to do with IQ versus EQ.
Oh, yeah, the EQ. That's another popular topic. Yeah, that's right.
So now they have a separate place where you are supposed to fill it up before you have your interview. And that is how they judge you.
Wow. And I guess you could go and read the website and see what they value. Their website's always going to have things like, we're an investment bank. We value returns and integrity. And, I don't know. I'm torn on this because sometimes it's just like fuzzy high-level words. And it feels a little like trying to push, a rope or something. It's hard to push a rope. But I think there is something underlying there. Like, I think there is something, you do this and it might surprise you. It might be worth knowing, like, here are the things I value. So there's Friedman has a nice TED talk about value-sensitive design. And here's again Robert Kozma about what is good. So, and you can again debate. Kozma says, here's what good is. It's not just being good, but doing good. So he doesn't really care what's in your head. He cares what you did. And religions differ on that, right? When you look at religions, they're like, is it your inner life or is it like what you actually did? So he's more like, what's your impact on the world? And then here are his 7 principles, moral foundations for good design. So I just don't want you to think, I'm saying this not necessarily like you have to believe this and this is the truth. I'm more like saying there are people out there thinking about the morality of design and the moral impact of design. So if you think that design is neutral of value, I don't think it is. Right? I don't think it's neutral. Some people say, oh, technology is neutral. You can use guns to save people or shoot people. And it's like, well, yeah, but there's going to be moral values in there. Like the US has way too many guns. But, yeah. Okay, so that is it for today. Well, not it, that's it for the morning. And then we come back, and this afternoon, I'm really excited to hear about your presentations. And we get tutorial 2. Where's tutorial 2? Tutorial 2, where we're going to write some speculative fiction. You're like, I'm a designer or an engineer. I don't write things. But we're going to do a little bit of writing. Yeah. Okay. So see you after lunch.
Fiction and speculative, what would be?
I'll define it. You can Google it too. You can Google it. It's a thing. You can Google it, or we'll just
about the same question what he asked.
Yeah, I mean, I mentioned NIT Rourkela.
Here they have signed some MOUs with other universities. Based on that, now students are made.
Something like that about they have answered.
So here in NIT Rourkela, there will be something called department for some department for international relations. You need to contact them.
Let's see if we can find the other universities. It could be too new, and so the website's not up to date yet. Let's see.
This is the first time they are Indian students are going there.
This is the first semester. Like they've been working for 2 years, I think, to get the collaboration.
Okay.
And now it's the first time they're really. Yeah. I could ask him if he wants to be on a Zoom call or something like that.
Yeah. You can ask that what are the requirements to fit into that particular program.
Okay.
Definitely there must be some requirements.
Okay.
If you ask that what are the requirements to be the part of that particular program, so what essential things that we have to do here to be the part of that.
Right. The faculty for university participate. Also, if they're interested in discussing this, that's your calendar. He's a busy guy, right? So I'm asking. Does that sound good?
Yeah.
Students. Yeah, he's friendly and creative. He's always thinking of new ideas and trying to.
Students also will be interested. But usually how this happens is in our university we have a Directorate of International Affairs. So there is a particular director for so when the foreign university approaches, we will have some series of meetings. Then an MOU will be signed.
That is required for everywhere. Admitting the mutual agreement, MOU has to be signed. Okay, this many students will go, this many may come.
Right.
What are the financial obligations for them, like that.
That's true.
So because they are paying some fee here, so what amount of fee they will pay there, like that. Some criteria they sort of those who are interested.
Yeah, and that would be important because the U.S. tuition is like the most expensive in the world. It's way too expensive. So I don't know if they're charging a lower rate or something.
Here also it is becoming expensive. Not exactly like it's relatively to when we studied.
Should we bug the students again?
Because like here, some students are going on the paid fellowship internship. They are going abroad also.
Okay.
Or let's say that you are having some project.
Yeah.
Let's say that you are having some project and that some openings are there. So you may put some advertisement you will put some criteria. If these are there, then you can invite you like that. Okay. And this is having some amount of fellowship, and these are the objectives that you have to meet with, and at that last you have to deliver this objective like that.
I was going to look at the U.S. Embassy for Fulbright because there's different opportunities, but I know about Fulbright more. I know that their website is very slow. Should we book the students? Who's ready? Who's ready? I can draw straws. I can say who goes, go poet 1, 2, 3.
Yes, sir.
So Fulbright program exchange program, US government. 8,000 grants. 300 fellowships granted annually. Master's degree. It's only for masters. Yeah, I was disappointed with that. But some countries that they offer PhD study too. But this is basically they'll send you over to the US for like a year to help do a master's.
No, research is there. Teachers and professionals to teach or conduct research in the
Oh, that's true. So you could come as a faculty member, or you could come as a teacher. Like if you're a K-12 teacher. Did they say K-12 grade kindergarten through 12? There's this term K-12 teacher. K-12 meaning kindergarten through 12th. I don't know what you call it here. It's like if you're, teaching primary school.
Kindergarten means LKG and UKG. Lower kindergarten.
No.
But here's
plus 12.
Yeah, K plus 12. So here's the thing with Fulbright is when you apply, you have to know somebody in the U.S. So I can be that person, right? So I can tell them, like, oh, you want to come study? I can, be that.
Oh, that reference.
Right.
Reference.
And because then you write in your proposal, I'm going to go to Iowa State and do this interesting research or something. If it's 0, I'll sort of stand up politely, and then maybe you'll think, oh, I need to finish up.
Good afternoon, everyone. Myself Sharon, and today my topic is: are racing games easy to play? Let's find out. So we played Need for Speed No Limits here as an expert and novice level. So this is a game interface analysis. As you can see, a car has to move through a certain point A to point B, and this is the main primary zone area. There are secondary focus zone, there are control area, touch points, obstacles are there, there are various directions are there from where you have to move your car, and there are also speed boost. So these are the interface, and what the human do, it has to go from point A to point B, a player. It have to maneuver through the narrow roads, traffics and obstacles, and they have to perceive information through visual cues in the game. The graphics and in-game physics provide the excitements which enables them to play the game, and there are also some frustrating elements maybe there, which is driving difficulties, skill set, which can be an issue. And the satisfaction level is the players gain rewards via game maneuver skill points, which acts as a satisfaction level. And the usability of the game can be challenging for the novice player. So we have two players here, one is novice and one is expert. So now let's see how a novice player plays the game. So this is the novice one playing the game. As you can see here, he is maneuvering through the traffic, but the one second, just yeah. So he's maneuvering through the traffic, but as you can see here, he's crashing around the game as he finds it difficult to how to maneuver the car. So how do I get through the curvy roads? How do I break through the traffic? So this is being difficult for the novice player. And as you can see here, the car is scraping against the wall on the right side. On normal way, we have to go to the left side, but at the same time, the person who is playing novice, he's not understanding how much to do or how should I maneuver this car. So he's kind of getting frustrated. So his cognitive workload is there. So he's kind of scraping the car against the left side instead of he has to go on the right. So to make the car move more faster. As you can see here. So the white dot here is the touch point. So this is where the person keeps touches the screen to go to the side. So as you can see here, the car is like scraping against the wall. So this area is completely free. So what we can see that the car can go left side, but instead of that, the player is very frustrated. So he is continuously tapping on the right side. So this is the novice gameplay. See, continuously scraping on the right side and now this is how an expert plays. What happened? Why it is not moving? I don't know. What happened? So you can see he can just glide through the curves very easily as he kind of memorizes the map where the curves are, where cars would be. So the novice player couldn't complete the race. So because it was a time bound race, so he couldn't complete the race, he ran out of time. So what was the reason behind it? For the novice player, it is difficult to understand the UI or the user interface, so which is maneuver skills are challenging for them to acquire in a short notice. And he can comprehend the road directions in short amount of time. So he had to process a lot of things at very short amount of time. So it poses a cognitive load onto his head. So he getting frustrated and he makes mistakes. So he can't complete the race during time. So as a result, his reaction times get slow, player gets frustrated, loses the game. And as for the expert, he completed the race under 37 seconds. So reason behind it is he's familiarized with the game, remembers the map. So this is the VSCP modeling of the game. As you can see, finger movement is the main crucial point here. According to the games, he have to see the lines and move his hand accordingly. So these are the improvements we can make. You can insert a mini roadmap here. We can add more prominent direction for turning that side. We can add some cue points, add little helping group tooltips in the game. And always you have to practice the game to be more expert into this area. And further analysis is perform longitudinal studies on gameplay, see the impact of different age groups, how the different age group can play, and see the impact of different context, in what mindsets the person is playing the game. Thank you.
Nice. Right on time. Does anybody have any questions for him before we go on to my questions?
Anybody has any questions? Any doubts? Yeah. So for the game, like you have to see the screen where the road is going, and you have to touch the screen according to maneuver the car from left to right. So there is only two perceptions here. Once you see the road and move the car according to the road conditions. So there is only two modules here. According to my.
There is also the sound of the car.
Yeah, but that doesn't affect that much. So the sound of the car is there just to add some dramatic effects in the game. So that doesn't defy the gameplay that much. So all you have to see is the road and where you are maneuvering through the traffic, maneuvering through the tight curves of the road. So that is the main factor here. So these two are, so as you can see here, VSCP, the auditory factors are very low, because you just have to register the sound for a dramatic effect in the game. So that's why.
Nice job. So you showed the novice crashing everywhere because of
Yeah.
the complicated interface. How long do you think it takes in practicing to be less of a terrible novice?
So as for me, I have been playing this game for like past 7 years. I'm playing this game. So as long as I remember, it took me around 1 or 2 months to get to familiarize with the game. Like for me, it's kind of a muscle memory. I know where the roads are. I know where the cars or the roadblocks will be. So, and for the novice player, he doesn't play games at all. It doesn't even play games at all. So for them, it is very frustrating. It's like where the car is going, where am I touching? So if you see the touch points in the game, despite of showing the car, you should have much more space to the left. He's continuously pressing to the right, and the car is scraping against the wall. So that part he's completely frustrated while playing the game. So
Yeah.
that's the part.
So I really liked your list of the human challenges, and the videos really helped, and the VSCP model was nice, and your improvements that you suggested are valuable as well. So I feel like you really followed the assignment.
Thank you, sir.
The only constructive criticism might be that when you have the list of human challenges, some of them you were just sort of reading, and it's always better if you can avoid reading the slide directly.
Okay.
And just sort of summarize, but it's not a huge deal. Yeah.
Definitely.
So who are your group mates? Who are the other teammates? All right, so we need to applaud for them too. Thank you. So nice work.
Thank you, sir.
Thank you. Let's get another team. Is that good?
Yeah, next team.
Good afternoon, sir. Yes.
Okay.
Shauti Das.
Okay, go.
So we have played a very simple game, that is cricket. Okay. So first I'll show the game interface. This is mainly in the cricket. There are two parts here. One is batting and one is bowling. So that red square zone is the primary viewing area when the person is batting. He needs to check the ball where it is pitched and he needs to hit the shot. So there are few controls, like in the below there are two, one greater than, one less than arrow, that is just used, that is these two are just used to change the position of the batsman. And then there is a shot power, that with which how much power he wants to play, and there is two types of shot, one is grounded and one is lofted, that he wants to play in the air or he wants to play in the ground. This is a batting. So with in our team there is one expert and two novice. So we played 2 over batting and 2 over bowling, and we calculated all the errors which can be done. During batting, first one can be done is wrong timing of the shot. If the shot is not timed properly, it either go out or it will be a dot ball, or it will be not going to boundary. And second is wrong direction of the shot. If it is on the right side, if the batsman wants to hit it on the left side, that is a wrong direction. And number of dot ball faced means the batsman cannot play the ball. And fourth is number of run not taken, because when the ball is in the ground, it's moving, the batsman needs to take the run. So that is a batsman judgment, that when he should take the run, otherwise he will get run out or he won't get the run. So here when we done the analysis, we have seen that in comparison to expert, novice have make more mistakes in wrong timing of the shot, in wrong direction of the shot, and number of dot ball faced. Same way, when we put it in the graph, it looks like that blue one is the experts one, and red one is one novice one, and green one is the novice 2, and these three are the trend lines. So it's clearly visible that the number of errors done by the novice are greater than the or higher than the experts. Same way, but batting is little simple because there are fewer controls. But during bowling, there are more controls. For example, this one is used to select the length that where that ball should pitch. And next one is the type of ball. It is going for swing, in swing, out swing, and then there is power of the ball, that in which speed they needs to play. And after that, the bowler should release the ball in the perfect release zone. If it is not released in the perfect release zone, it may get into extra deliveries. So there are 5-6 controls they needs to do, and here are actually 2 guess points. The red one are the primary guess point, and this one is the secondary guess point, because after adjusting the primary guess point, they have to see where the secondary guess point is. So as you know, so in the analysis parameter for the bowling, there are number of errors are high. First one is the length setup. Length setup means this one. This one if they have missed to set. Next one is number of speed setup. Speed setup is this one. Same way, where when we do the analysis, we have seen during the 2 major mistakes have done by the novice are the run up selection missed and the number of release zone selection missed. Run up selection is this one. This is automatically showing it will end by 16 seconds. But as when we are playing here, there are many auditory cues outside. So it's already there is sound. It's a light. Yes, sir. It's a clock sound, so it is little less perceptible when there is outside auditory environments is there or outside noise is there. So these are the errors. Same way when we have done the analysis, it has seen that experts have done less error than the novice. So the final game result is experts have taken less time to finish the whole game and novices have taken more time. Same way when you done the accuracy, this is the accuracy done by the during the batting and during the bowling. So after that we have done VSCP modeling of the cognitive load. So I found that during bowling the cognitive load is higher in the novice person. So what is the reason? Because as you know, we have 2 cells, that is rod cells and cone cells. Cone cells are mainly responsible for the color visions, and there are total 3 types of cone cells, that is S, M and L.
Yeah, yeah.
So they are mainly detect red, blue and green, and rod cells are extremely sensitive in low environment. So the scope of environment is the user perspective. First, they have some prior knowledge of the game, that if they have the basic knowledge of the game, it is very easy to learn the game, and second, they need little bit more practice. So from the game's perspective, there is a release zone indicator. This indicator, as you can see, it's white line. If this white line, they have missed maximum time. If this white line can be made as little bright color like red or something, so it is more visible. And second, additional cue for the run up. For example, run up, there is a very small sound. If there is a little bit vibration or if the color is little bright, they can easily select the run up cues. And the color of the ball pitch position, it's white. If it is a little bright, the novice players can detect it very easily. This one. And yes, sir, that's it.
Right. Any thoughts or questions, reactions? I really liked your bar charts with the trend lines and your analysis of both batting and bowling. Can you go to one of the data charts where it's got the percentages of errors?
Yes.
Can you go to one of the slides with me? Yeah, there. So this is a very small thing, but the charts like that look better when all the numbers have the same number of decimals.
Yes.
Like some numbers have 2 decimal points, some have no decimal points. And if you right justify them, like
Okay.
tables of numbers are good when they're right justified.
Which one, sir?
When they are right justified, like these are left justified.
Okay,
so,
okay.
You know, and you move them all to stick
Yes.
them to the right, and then they look good because when the numbers are on the right, if there's like 1 digit versus 2 digits versus 3, it's really apparent what a big number versus a small number is.
Yes.
So that's a very small thing, but very nice analysis, and I appreciated your throwing in the retina as a thing in the contrast.
Yes.
Yeah.
And also, if someone is little challenged like color vision or something, if there is a red color, they might, if they have the protonopia, they might see it as a black, but still it's visible. But upon that light color pitch, when there is a white spot, it is sometimes little less. It's difficult for them, for novice people to view, because it's very small amount of time to release the ball in that position. They need to adjust. So that way, if there is a little bright color, it will be more. It is easy, and they are my team members. So
Yeah.
I have also asked their feedbacks. So what they have said. So they said that if there is a little bright color, it will be easy for them to spot.
That's great. Do you know what percentage of people are colorblind?
Exact percentage.
Which way?
Exact percentage I don't know right now.
It's about 10% for
Yeah.
men and about 1% for women.
Yes.
Because it's carried on the recessive gene, you know. So you
Yes,
got
it's X chromosome linked.
So in this room, there's probably 2 guys who are colorblind. I don't know if you really, but yeah. Okay, so thanks for thinking about that. Nice job. Yeah.
Thank you.
Okay. A very good afternoon to all the gentlemen present here and the lady. So today I, Riya.
Hi Karnesh.
I am Kiran.
I'm Tej.
We're going to analyze the game that Karnesh and Kiran are a pro at, and me and Tej are a novice at. So going ahead, he's going to tell us, Karnesh is going to tell us what really the game is about.
So basically game is all about there are two opponents, one are we and another opponent is playing virtually with a means online. He's connected to us online. We are playing on a same server. So as you all can see, first when we enter to the game, we are at the lobby. At lobby you can see we have mentioned that there is a level top corner. Yeah, that is the level of our player, and then we have the power, how much power are all the equipments and every combination weapons we have. So total power it shows it there, and the energy bar refers that how much time we can play the game. Okay, then we have the currencies of the game like fragments, coins and gems. These are the majority currencies which lets us use to buy something or to claim the rewards easily. Okay, moving to another thing, we have the inventory where we can select the skins like costumes or any other stuffs which we want to change the appearance of our character. Then we have the reward sections. Reward basically we have uh, four slots for our reward section. Okay, so at a time we can contain 4 rewards and we can open it by the time duration. Now we have simple rewards. For if we open it, we can get the access for 2 hours at least. And then we, as you can see, we have inventory and other slides. Okay, this is our inventory. Here we can select the arrows. Okay, select the arrows and check it, choose it for our means for our suitable gameplay. Okay, passing on to my another teammate.
So the inventory basically allows us to increase our health. This is the play area where we get to see our health. Based on what we have selected, our health increases. As you can see here, both the health of the opponent and our health is same, but it can keep on shifting. We are able to see the shield health as well. So basically, the area which we see, it allows us to view a few things. First of all, the environment that we have, it keeps changing. It randomly gets selected. It is dynamic. So the height of these mushrooms keeps changing, hence our trajectory shifts as well. Can you play the video as well? So that we'll just get an idea of what the visual is like. And then here, while we're selecting what to play, we're also able to see what was the last direction that we took our arrow in. But the twist is that with each round, the wind strength and direction changes. And that also shifts how much strength we're going to take and how much direction we're going to pull it at. Each shot has a 15-second time limit, and the person who decreases its health to 0 loses first. So just to let you guys know what our gameplay consisted of, we had 2 experts, we had 2 novices. We also observed that there is a difference between how the novice and the experts hold the mobile phone. For example, we can see that both the novices were more interested in putting the phone down, being very careful about what their hands are doing, whereas the experts were so confident they took the phone in both their hands. They were playing with their thumbs, whereas the novices were playing with their fingers. The experts won. One of the expert won. The other lost in 2 minutes 33 seconds, and both the novices took much more time than the experts. The amount of rounds for novices were longer as well. The strategy that both the experts like to somehow play without the audio, and they were also like Karnesh was aware about all the inventory and what are the game effects, which arrow that he selects, what does the arrow that he selects does. Whereas both the novices were completely unaware, they were selecting just by chance. The targets, the novice strategy was that he was selecting, he wanted to target the head and the boot because there was no shield available there. Whereas the novices, they were only paying attention to the wind direction, and even they. Is it time?
So it's,
1
it's
minute?
5 minutes, but
Okay.
maybe
We'll-
finish a thought, or you haven't gotten to talk yet, or
Yeah,
I don't
okay.
know.
So basically, both the experts like to play it without the sound, and the novices wanted to use the sound. And especially for me, I was getting a good idea about how much time is left because of the audio itself, because there was a tick, 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 tick sound.
Sir, I will take over now for the main thing where we have to focus on the game. So you can see this is the screen when which the players are playing. This is player number 1 and that is player number 2. And this region that is bounded by the red dotted lines are the region that needs to be focused at. So you may see the birds and the mushroom. These are interactable objects. So if the arrow is being hit over here, the object will get removed, or else the arrow will not affect the opponent. So when the striker has been pulled, this is the point where from where the striker has been pulled. This is the line that is showing the how much power has been given to the bow. If this line is shorter, the bow's strength will be less, and the focus where the main focus of our team is going on is the direction at which the bow is going, and these obstacles needs to be avoided. And this is the point where we have to focus after we have shooting the arrow. That is the wind direction. If the wind direction is over to this side, the arrow will gradually lose its trajectory and it will fall down. And the last focus that we need to focus is the health that we have. This is the remaining amount, and we have to check it, because if the remaining amount is very less, we have to take a defensive approach for the attack. And the last point is
this one we what we learned from this is that it was very subjective when we did this cognitive modeling, and the novice was scoring it differently from the expert, so we took an average of that, and what we had to do was we had to learn where the task begins and where the task ends, and we have to understand the hierarchy of the task and what is the importance of the task to maximize the final output. And the other thing was the expert may undermine some complexity which the novice may think is more complex. So those things we learned from this VSCP modeling, and that this is about VS.
Okay, the last point that sir required was that if we had the time and money. So for the experienced people that would like to play the game more, so Karnesh, he's the most played time, so he likes to get his rewards faster. But for me, it would be to get higher chest so that we can get the higher level rewards. And for Dia, it's probably playing this game. She doesn't like to play, so she won't play at all. And Tej would probably do the same because he is also not interested in the game. And thank you, everyone.
Okay, nice. Any thoughts, reactions, questions? So I really appreciated your trying to do the collaborative speaking, right? Because it shows team engagement. It shows that you're all involved and you all played a big role. The timing, though, shows that you also have to practice that, right? Because so I didn't stay on time. But it was also nice that you were able to leverage your team by having all of you up there. So like Ria was pointing at the screen while you're talking, and that's really helpful. I liked your player slide. Can you go back to the player slide with the 4 players? That's a really nice slide because it gives me one glance, it gives me the overview of everything that's going on with the strategies and the times. So that's really nice. You had the strategies on there. And I think for the other teams, right, most teams are doing like 1 expert and 1 novice. I think it shows here on theirs, they had 2 experts and 2 novices on how much more there is to say just when you have a little bit more people, right? And it's not necessarily better, they just happen to look out that way. But as soon as you start adding multiple experts, multiple novices, just things get way more interesting. And you can start doing averages and looking at strategies. Yeah. So when I teach this in a class and they have like a month and a half to do it, I'm asking for like 3 experts and 3 novices, you know, and they have more time, that sort of thing. One tip is that I think when you were talking about the screen, you were facing the screen. So it's not as good to have your back to the audience, right? Because then you lose them. They're like, who's he talking to? He's not talking to me. So it's hard. You have to practice that. You look like a weather person, you know, like where you're like, oh, you know. But it's something you can practice. Yeah. On the if you had more time and money, I appreciated what you had in there, but I was thinking more like, if we were researchers on this game, what would you do?
It was a last
Yeah,
minute edition.
yeah, no, that's fine. Yeah. So nice analysis. Okay, thank you.
There was just like a few points he forgot to mention. For example, we saw that the expert, he was not zooming out to see the trajectory because he was so experienced. It's his. And then the second one was that I could not figure out the control because there were two options. Either I could throw it or I could use it as a slingshot, and that was not very clear. So maybe that's something we would work on if we had the time.
That's right. So thank you. So let's think while they're taking apart. Let's think about what you just did, right? You did a really nice analysis in less than 24 hours of this game situation. You may think, oh, this is so simple a game. I hope that one of the things you realize is that games are not simple at all. Right? And that's why game studios will spend millions and millions of dollars to develop them. We had one student who went off to Pixar, and he was part of working on some games on there, and he came back after a while. He's like, I spent 5 months on a character's hair. He was making this one character's hair beautiful in all the different game situations. But there's a lot of complexity. And so what are some of the differences? That we do this game analysis activity to sort of practice for cognitive engineering of a real situation. So what are some of the differences that you would have between the analysis you just did and a real situation, like you're analyzing a hospital or you're analyzing a factory, or what are some of the things that would be different?
Multiple occurrence at the same time.
Yeah, and that's the biggest thing, is multiple people at the same time. So I restricted this to single-player game because it's complicated enough, right? But as soon as you get multiple people, they play different roles, and there's collaborative people, but there's also bosses and under the bosses, and that dynamic is a whole thing. So that's a big deal. Yeah. What else?
Like lack of control in real life situation, we can't restart whenever we want.
Yeah, that's right. Yeah, I can't go to the factory and be like, y'all stop working. My counter is off, or something like that. Right.
Some of them don't even allow anyone to actually watch them because sometimes it's a matter of life and death, and you never know someone's being miss.
Yeah, that's right. We had for John Deere. I don't know if you've seen these John Deere sprayers that have arms. It's like I'm driving this tractor, and then it has these arms, and it folds out, and the sprayer arms are really long, and they're these triangular metal meshes, right? It's long triangular mesh. So Deere figured out that on those triangle metal meshes, if you miss 3 welds, like you screwed up on the welds, and you miss 3 of them, then it's going to be likely to break in the first year. So they really wanted us to we created this monitoring system to watch, did they get all the welds? And it's actually sort of hard for some of the workers because it's a triangular mesh. It's not like just count 1, 2, 3. So when we were doing this in the factory, a lot of the workers were like, I don't want your cameras in here. And we had to talk with the union. Do you have unions here? Yeah, so we had to talk with the union, who were like, are you going to hurt our workers? So just the logistics get way more complicated. Yeah, but you can do it, right? The same principles you just used on the game, and y'all did some really nice analysis over a quick span of time, and you can do that in a real setting as well. It's just going to take way longer, and it's going to take some more thought. And in a couple, I forget if it's tomorrow or the next day, I'm going to be asking you to estimate a budget for doing such a thing. Like, how many people do you think you need if you were going to do this for a company? But any other comments on this activity? I hope it felt interesting. It wasn't a waste of time. Yeah. Okay. So let me go into this other topic. And again, really nice work. I realized maybe I should share some of the reports I talked about in my class where they have the 5 weeks or whatever. And a couple of the students did really nice jobs. And I would say to them, can I share your report with other students? And they would say, sure. And so I've got some of those I could share, and you might be interested in their analysis. Okay. Let's see if I can get going here. All right, let's talk about speculative fiction for a minute. So what we're going to do here in our remaining time and before tomorrow is write a brief story of the future 10 years from now. And, you know, it could be any sort of thing about the future. It could be, I'm going to learn a new skill, I'm going to eat differently, I'm going to interact with my friends differently. It can be creative. And the thing I want to emphasize is that sometimes students tend to make it like a product pitch. Like, oh, I'm going to have this technology, it's going to like customize medicine for my body, and it's going to be awesome, and I'm going to take pills, and I'm going to feel better immediately. And I need more of a story. And so I say include a person who has a name. So it may be, you know, Banu. And Banu wakes up in the morning, and Banu says, I have this need, I want to do this thing, and and then I'm going to use the tool or use the gadget, but you got to tell a story about a person. And I'm big into storytelling. A story has a challenge and a resolution, right? So the traditional story is like, oh, I'm a knight, I have to go fight the dragon or something, and there's a big dragon, and I fight the dragon, and then I rescue everybody. So in the business world, you need these stories as well, because if I'm going to convince you to give me 1 million rupees for something, I need to tell you a memorable story. Most people are convinced more by stories than a big data chart. Like maybe I do need a chart about like, you know, with this intervention, you're going to save 10% on your sales or costs or something, but you need to have a story in there, because then they leave the meeting and they'll forget the bar chart, but they'll remember a story if you have a story. So this will be groups of 2 or 3 again. I would encourage you to get in a different group of 2 or 3 if you are daring, so that you get to know each other a little bit more. And part of that is be sure to introduce yourself, you know, like, hi, I'm so-and-so. You know. And then this is going to end up about 150 to 200 words. Any questions so far? So try not to stick with your same group, even if you love them. I mean, it depends on you. You can do that if you want, but
Would it be easier to do it individually?
Sorry?
Would it be easier to do it individually?
Do it easier in the...
In solo.
Oh, solo. So yeah, so life is easier when you do it yourself, but in the real world, that's not the way it is. So this is also practice, right? And so you might negotiate, and you're just like, oh, I want a special pill. And another person's like, no, we're going to have, lion attraction devices. I don't know what you're going to have, So you'll have to decide a little bit on what's a more impactful thing. And then I'm hoping you'll analyze it at the 3 levels of the system. So you're going to have the story about using a gadget, and then just a couple sentences for each level. Like we think that at the micro level, this will help people accomplish their work better. We think that if everybody had this, it would build a community around people doing X. And we think it could affect the culture this way, or it might not, But we're going to see more and more of this AI coming in where it's going to hit the culture, right? We're already seeing, at least in the United States, a lot of professors are worried about the AI and cheating and all that. So it's changing the culture of college and universities, just by being a piece of new software. Okay. So this is a little bit about what speculative fiction is. Who reads fiction? Does anyone read fiction? Okay. So I like reading fiction. Not everybody. I've had students, especially, I have a lot of Iranian students and Chinese students, and they'll come and I'll say, you need to work on your English. I suggest you read some fiction. Because if you read the fiction, then you have dialogue between characters, and that sort of helps you practice normal talking. And they're like, well, fiction's a waste of time. And I'm like, actually, it's not. so let me tell you why it's not a waste of time. And by the way, here's some books I read recently. I tend to be a little more into science fiction. This is one called, it's one of 7 books that are all very short, and it's about a character named Murderbot. And it's interesting because Murderbot is a robot, sort of robot synthetic human, who is supposed to be a killer guard, sort of defender robot, but they don't really like being that role. So it's like they're built to be a certain role, but they don't like that role. And so all throughout, they're like, I don't want to kill everybody. So that's interesting. This is about the environment, and that's just sort of silly, like if we had another world with dinosaurs and stuff. But they're well written. Has anybody heard of Ray Bradbury? Okay, so the science fiction devotees. If you download these slides, you can click these links and get real short stories that are just out on the internet, because he's been dead long enough that it's open source now. This one is scary. like it's sort of like you read it and you're like, ah. Maybe a little scary, not as scary, but relevant. And this one is also a little scary. So Ray Bradbury is famous for science fiction and also horror stories, but they're not like bloody, gory horror. They're more like things that make you go, ugh. No. So I encourage you to read some of those. So speculative fiction is any sort of fiction that asks what if. Like, what if we had this technology? What if we all lived on Mars? What if, and it's asking what if. And when you're designing products, you're sort of doing the same thing. And that's why we're talking about this. Like, I'm going to design a product which is asking, what if they had my product? Wouldn't people be happier? So we're going to try to look at some stories that way. There are lots of kinds of speculative fiction. You might have heard of dystopian, utopian. The dystopian is some future terrible world. Utopian is a happy world. There's a smaller genre of alternate history. There's a good one called, let's see, it's The Tower, The Tower, about what if the Nazis had won World War II. It's like The Dark Tower or something. Apocalyptic, fantasy, superhero. Okay, so there are different genres. And Isaac Asimov is a famous author, a science fiction author. He came up with the 3 laws of robotics. And it's a really clever book approach. He's got this book, I, Robot, which has nothing to do with the Will Smith movie. But he's got this book, I, Robot, in which he says at the front, what if we had the 3 laws of robotics? That robots cannot hurt other humans, and robots cannot hurt themselves, and I forget the 3rd law. It's like robots can't, it's things that make sense. And he's like, you read them and you're like, oh, that's good. Our world is going to be safe from evil robots if we have those laws. And then his whole book is short stories about how things can go really wrong despite having those laws. And so in the 50s, he's thinking about what now people are thinking about as AI and ethics. And he spent the last days of his life in Sri Lanka too. I don't know if that's regional interest. So part of the other interesting reason is that science fiction leads to technologies, right? It can inspire new technologies, And so here's some examples. 1865, Jules Verne writes From Earth to the Moon, like, hey, we're going to go to the moon. And then finally in 1969, over 100 years later, people go to the moon, right? And in Star Trek, there's this flip phone, basically a flip phone communicator, and then years later we have it, right? 1887, the idea of a credit card comes along. Financial technology is really interesting. Who knows where stocks were invented, like buying and selling stocks? Anyone? It wasn't the US. It was the Netherlands. And so they had, there's this idea of puts and calls and options, and they came up with all that stuff, and it's really impressive. And then Ray Bradbury has a book, Fahrenheit 451, which is sort of famous, but not actually that pleasant to read. But he talks about basically what are AirPods. Yeah. So that's an example of the science fiction. People dream up stuff. There's an author named Werner Vinge who has a book called Rainbow's End, and in there he's got the contact lenses where they're little screens, and he's got clothing, so when people shake hands, it like communication data passes and this sort of thing. So I haven't seen that yet. Okay. So why read science fiction? Turns out, research shows that it actually increases your ability to be imaginative and flexible. So if you're thinking it's a waste of time, you might try it a little bit because it might expand you some. And there's a really nice TED Talk. Do y'all know TED Talks? People watch TED Talks sometimes? Yeah, okay. Jane McGonigal says, okay, if you're going to imagine the future, you need to do it in these ways. And it's also a good way to explore perspectives of others, right? We talked about the empathy and the taking perspective. So in science fiction, you're writing or you're reading, and it enables you to think like, oh, what if this were different? Here's a different perspective, right? So here are some actual research studies that I think I've got in my folder. Reading literary fiction improves theory of mind. Theory of mind is a term from cognitive science that's about understanding other people's thinking. Here's something you can try if you have 4-year-olds or lower in your life, like a niece or nephew or something. 4-year-olds, 3-year-olds and 4-year-olds don't really have theory of mind yet. So they think that everybody has the same knowledge as they do. And so the scenario is you ask them you say something like, I've got, do people do Sesame Street here? Cookie Monster and all that? Not so much? Okay. Well, anyway, you've got two people. So I've got Alex and me, and Alex has these really good cookies. And you're telling this to the 4-year-old, like, Alex has great cookies. And you want the cookies, but Alex won't give you any. And so Alex puts the cookies like under the table in a chair and walks out of the room. And then when you come in, I'm not getting it right. I'm sorry. Okay, the point is, let me see if I can get it right. The cookies are on the table, and then okay, there's two people. And the point is that they'll hide the cookies, and like, I want the cookies, and I don't know that they're hidden. But the 4-year-old will say, they'll be, where will Stephen look for the cookies? And they'll say, oh, Stephen will look in the chair. Because they don't know that people's brains are different and have different knowledge. And so you can test your 3 or 4-year-old. If they get this, then they have theory of mind, meaning I have the ability to imagine other minds that are different than mine. Yeah, so there's empathy there, and there's more theory of mind development in preschoolers when they're doing some television. There was plenty of research on, like, oh, TV is bad for children. But if you are exposing them to these stories, and then fiction stories that are interesting, it can improve their theory of mind. Okay, so the future vision story is key to product design. If I'm asking you for millions of dollars in a new product, I need to tell you a story. Right? So that's what Shark Tank is all about. If you watch Shark Tank, there's, person comes out and like, here's my story, and it needs to be very evocative. This is something that Pixar does when they're making movies. They have this framework. Once upon a time, there was a something. Every day, something happened. One day, something happened. And then because of that, something, and because of that, something else, and finally this. So they can use this and fill out the whole plot of a movie or for a product. Right? So let's imagine it's filling out this story for a product. Once upon a time, there was an artistic couple, live in a charming guest cottage. Every day they left, and they wished they could have more money. One day they discovered an extra way to earn money. And because of that, they're able to pay off. Okay, do you recognize this as a service or product? This is a true story. Asheville, North Carolina is where the sort of hip, rich people live in North Carolina. And it's a beautiful mountainy area, so they've got this cottage, and they want to rent it out to people. It's a service. And which service is it? Airbnb. This is the story of Airbnb. So Pixar would say every product can, you can have a story that fits in this template. How's our time? Okay. I'm not going to watch this one. It's about 7 minutes long. But what's interesting is that in 1987, like ancient tech history, Apple rolls out this video of what the distant future would look like in 2011. So it's 87, and they're projecting to 2011. And if you watch the video, it's a professor who's interacting with this iPad-like thing. And it's on his desk, and he opens it up, and it unfolds, and there's this butler-like figure talking to him about, well, your students left you some messages, and your mom called, and this sort of thing. And then he collaborates in like a Zoom-type interaction. And what's really nice in the video, you're watching it, and you're like, oh, it was so easy. They didn't say, can you see my screen now? Like it's just sort of seamless. So there's a lot of future features in here that Apple then actually did build into iPads and into Siri. But the butler is named Phil. The butler figure will also say things like the professor is preparing for class. And the professor says, oh, I need some new articles. Show me all the articles on climate change I haven't read yet. Right? And you're like, So, is that okay to have an agent like Phil monitoring everything I read in life? And then there's another nice time when he's collaborating with another professor on the Zoom, and she's like, you just want me to come to your class because you're desperate for some content for your class, aren't you? And he's like, oh, no, that's not until, and Phil chimes in and says, that's not, 4:15. So like none of our agents are ready for that, right? I mean, ChatGPT is nice, but none of them are able to hold a conversational thread and monitor it and like intervene and interrupt at the right time. Like we're just nowhere near that yet. So it's a good reminder of like what could be. And one of my papers that I wrote recently with my team was asking, why don't we have this yet? Why don't we have Phil in this gadget yet? And it turns out it's not just technology. There's a lot of like privacy issues, that sort of thing. And my favorite concept in this paper is the idea that let's say I'm a professor and I work with this butler Phil for 10 years, and then I'm retiring. So I might want to sell Phil as like an agent on like the eBay of agents. And what's interesting is that if it's a human assistant, like a human administrative assistant, they're good at saying like, okay, I've worked for Stephen. I learned about Stephen's personal life and I went through, his department chair of dysfunction. I went through all this stuff, but I know that with my new employer, I'm not going to talk about that stuff. So there's a difference between private and public. But it's really unclear how an AI agent would do that. Like if I'm going to sell Phil, how do I make sure Phil doesn't tell people about my personal stuff? And I've seen nobody in AI talking about that yet, about this like different types of information in private public. But oh yeah, and the point was we're doing speculative fiction. This is a speculative fiction about the future of Apple. There's a Microsoft one from 2015 that looks very, everything's white and tan and yeah, it's interesting. Anybody watch Black Mirror? Is Black Mirror popular? Yeah, so it's a series that is like what would happen if, it's speculative fiction, like what if all our brains can be downloaded into VR sort of thing and you never die, you just live in VR. But it's a lot of different episodes and they're all sort of scary and negative. I mean, you can't watch too much at once or you'll be feeling like the world is terrible and falling apart and people are evil. So I would say dose carefully on that, but it's very powerful. And if you like that, then go and find episodes of The Twilight Zone from the 50s, which are also about tech future. So it's from the 1950s, but they have really powerful stories of what the future might be like with technologies. If you like this story also, I put there's a Substack or, it's like a listserv that I read about AI, and it's got AI news, but also every episode. So it'll be something like Meta did this thing with AI, and OpenAI did this thing with AI. And at the bottom, it has tech tales. So it's about 500 words about what the future might be like, given the news stories you just saw above. It's sort of clever. So if you like that. Okay, so we're back to our assignment. We've got this and this. All right, so I'm going to ask you to get in groups and start some ideas here for 30 minutes, and we can walk around, and then tomorrow you can come back and bring some stories to us. Okay, any questions? Do people need help getting into groups? We can just count off randomly, right? And then you're stuck with your group that we count off.
So I have a question. This story that this is a story, not a product pitch.
Right.
So, what are you expecting from us by writing the story? That's what I'm trying to do.
Yeah. So I think there should be some character who's going to use the system, and then you tell me about how it affects their life, something they do. So it's like I could say, I've got a new product for you that is, it's integrated with your backpack, and it's like one of these water bladders, and so you don't have to have a separate bottle, it's always with you. And instead of selling you like, I have the coolest water bladder, I'm going to be like, so John likes to go hiking, and when he's hiking, he hates carrying water bottles. And so instead he carries this water bladder, and it can fill up this, but then, or something like that. So you can talk about it, but
So
inside
like
a story.
Commercial. So it's like a product commercial, but not a pitch. It's that kind of
Right.
thing.
I think because if you think of it more as a story, it lets you talk more about the impact on John. And you can also think of products that don't exist at all, and you don't have to explain. I mean, you can just assume there's magic. Like, oh yeah, I'm going to have tooth replacement that's just going to happen or something. I mean, I don't know. So you can dream up things, right, that we wouldn't think are happening. I'm going to go and pick the hair color of my child or stuff. I mean, I don't know, right? You can start doing some of that stuff now. Okay, does anyone want help finding a group group mate. It could be like you said, 2 or 3 people. I mean, so it could just be 2 people. Maybe it's easier, 2 people, less arguing. I don't know. So we could just let people, you could wander around and pick, or I could do 1, 2, 1, 2 sort of thing. You want to do the random number? You want random assignment? Okay. Be better? Random assignment. Okay, because then you're not like biased towards somebody. Okay, so how many people are playing? How many people are going to do this? Is everybody? Are y'all doing it? You doing it? Okay, so 1, 2, 3, 4, 5, 9, 10, 11, 12, 13, 14, 15, 16, 17. You want to do it? 17, 18. Okay, so we're going to have 18 people, so we need, would you want teams of 2 or 3? 2? Yeah, 6 groups, yeah. Yeah, you could do 9. Sorry? 3 is more collaborative, okay. All right, so we're going to do 6 teams then. You ready for 6 teams? Okay, so we're going to count off 1 to 6. All right, so you got to remember your number, and then you're going to join the other people. So you're 1. You say 3. 5. You say 5. 5. 6.
7.
Oh, wait, sorry. You're 1. You're 1, because we're only doing 6 teams.
Okay.
So 1. And you're 1, 2, 5, and you're 6 at the end. Okay, the 1s, raise your hand if you're a 1. So y'all get together somewhere. Why don't you come over here with him? The 2s, who's a 2? Okay, so y'all get together somewhere. Who's a 3? 3s. Okay, y'all get together, maybe up here, there's room up here. 4, who's a 4? So, yeah, join up. Who's a 5? So maybe back there with him. Who's a 6? You're 5. Yeah, so 5. Sorry. Who's a 5 again? 5s. Okay, so you all shoot the red shirt people. 6s then. Okay. Did this work? We're good? Okay.
I was doing that presentation. Actually, I was not aware, so I just came to know about presentation at 2 o'clock. So I was trying to build that gameplay thing, and I was working on a game which reacts. Basically, the game it's a game that is used a lot of psychometric tests. So I was trying to build this kind of thing. So it looks at what kind of neurocognitive regions in the brain you engages.
So it's like we've got a bar chart here.
Yeah, actually, yeah. So this is psychomotor spider. So what are the major? So in a recap. So I will be sorry. Actually, I was not able to do it.
Oh,
At 2 o'clock only I came to realize. So I have to get a game, then get a result, and yeah. So this is that I'm doing. So it looks basically what are the functions that you require to use while they gaming, and what are the areas where you do it. Then they are visual and cognitive. Psychomotor is very less, and auditory is very less because so I was doing this, and also we are figuring out VCAP distribution. So which area of the game?
Okay, I'm worried about your story. I'm worried about your group may not be happy.
Actually, I'm not even.
You're not in a group?
Yeah.
Oh, I thought we were counting you.
Because I think the city date, so we were
Okay. Okay.
That's why I was.
Okay, sorry. All right.
Maybe if you see the game, then you might get a better understanding. This is a game.
So what's your goal with this again? I missed that in the front.
So this is a game that they use this. It checks the response time.
Yeah, sure. Okay.
Yeah, so let's try to figure out how good you are at visual. This, right?
Yeah.
Cue between your visual and cognitive load, like
Yeah.
how do you, and there is this thing and there is a reverse mode. So first you were trained on doing it at the right color, then it is a reverse mode. Just basically figure out if you have a new level of information that you have to do tasks. Just suppose it, how much time it does take for an individual to do it successfully to reach the same kind of a score. Or 65 times you are doing this.
Mhm.
When I change the information order, that every time you see a red, you have to press happens.
Yeah.
So what kind of basically on the basis of the scores and indexes, you figure out what are the things that you require. So there, at one stance, there are sound, and at one level there is a sound, not sound.
So is this about a task or about an individual human?
It is about an individual human, also about the task. It's easy to figure out. For example, there are 4 kinds of stuff
Should have as it to be only a product based, the story which has to be the story which has to be
I mean, it can be a story about somebody using something in the future that doesn't exist yet.
so as a user.
Right. Yeah. Okay. Let me get my slide up. Okay. Let me get my slide up. Is it still on? Okay.
We select one of these scenarios, or do we take care of all three that you mentioned?
No, those are just me making up scenarios. You got to do your own. Yeah.
And how do we submit it in the end? Do we mail? Submit it in the end? Do we mail?
Yeah, I don't know the best way. You could email. So here's this, and then here's to make sure you analyze it at the 3 levels. And maybe I'll say here, I'll just put my email on here. Email to. Okay. Does that work? Okay. Those are just examples. So the real requirements are in the yellow. The yellow is the requirements, and then the analyze at the 3 levels. Okay. Is that good? Hey, sorry.
To understand the levers and how to match the levers. You know, there is a hierarchy of understanding, like levels of teaching, treat and theory.
Yeah.
And theory of mind around also there is an idea how you understand and you work on. So it's basically understand how much it's a time for an individual to figure out what are the dominant sensory inputs that you have to focus upon. So sensory input as we are another thing. Even simple things. We figure out what is the dominant input. First, one time there are 4 rings. At one time we are like the sound is off. So we are trying to figure out is there any difference while switching off one of the 3 stimulus with the audio.
Okay.
What you say is there is a sound. So at one point there is a sound where for different colors there will be different sounds. At one point there are sounds where there will be no sounds. The difference is constantly the same sound. It's like a noise, right?
Yeah.
So we're trying to figure out whether the noise or the audio have some effect on an individual. So for a normal website, it does not have any impact. You can see the audio is 6.5%. It's all about the visual cues.
Yeah.
Whether the color is red or red, then based upon you will be choosing that.
Yeah.
So for a normal individual, trying to figure out what is the response.
Okay.
How much time it takes for an individual to figure out what I have to do and how much like you continue. How many times.
And you want to compare with like people with autism or something, or like why do we care about how long it takes?
So, I was thinking about this particular thing. Gives you a good understanding when you have a certain sense of information, how much time it takes. Because you know the rules. Rules are very simple. You have to just match it. It's not a big game. And there is no other way to do it.
Yeah.
The speed is going to increase and there is nothing. There will be no corners, nothing. It's a very simple game.
Right.
Even with a simple set of rules, how much time does it take for a normal individual to speed up its performance? For example, you read a one book or one novel, or you learn how programming works, but how much time it takes to process this information and implement it in a psychomotor. So integration between the information and the psychomotor reflex. That's what I'm trying to figure out.
Okay.
Yeah.
And then what are you going to do with that if you figure it out? Let's say you
Figure
figure
out,
it. If you figure it out, you're very successful. You have all your time thresholds. And
Yeah,
then
this
what
is
do
the
you do?
advantage it takes for a normal individual for this amount of information. For the one set of rules, it takes this. For the three sets of rules, it takes this. For the
Yeah.
eight sets of rules, it takes this much amount. We can basically figure out, understand. For example, we have to train somebody about something. Okay, it's a software system. We want to train about PPT, like visual-based software system. There's no course, right? Visual-based, like PPT or ArcGIS or anything. How much time does it take for a normal individual to successfully learn that program?
Right.
And we can also figure out for a one personality type of individual, which is the dominant sense, which is the passive sense. So there is also for this particular set group I have for the two people. So dominant was the cognitive.
Yeah.
But for one guy it was visual. So we can add a lot of information, figure out this kind of individual, they have a dominance of cognitive. So you might have a different strategy to teach them that particular software. I'm saying GUI based software.
Yeah. So if this is hard to do, if what you're proposing is difficult to do, it might be that people will just say, well, if I want to know how long it takes them to learn PowerPoint, I just time some people, and I don't have a model of their cognition, but I just have some times, and that's enough. But it might be, if this is not too hard to do, then it's really valuable because you could estimate the training time for software that doesn't exist yet, maybe.
Yeah. And also, I can help an individual. For example, I have a target group of government clerks, and I want to build a software for them.
Yeah.
For feeding data, entries, or whatever the reason. Now I want to have a data content. Like I want to collect the first this test. I will run and figure out what are the dominant rights, what is the dominant set for them, and I will design the software according to that dominant sense.
Yeah. I think what's hard is whether this is modeling the task or modeling the human. Because it's
modeling the task is easier. Modeling human beings is much harder because it will take a time. The biggest constraint we are having is time. People will learn this basic rules, but how much time they are going to take?
Right. So then maybe that gets to the human more.
Yeah.
And then if there's a lot of individual variation, like today I haven't had anything to eat and I'm a little tired, versus tomorrow I'm all revved up and ready to go, then maybe the times are different. So is that okay?
Basically, it's one of those things, so I cannot make a substantial result. It's just a basic idea, understanding about the ways, suggesting how to do a team analysis and figure out what could be possible use cases for this particular.
Yeah.
So it's not about, there is one thing, people strive for efficiency.
Yeah.
People need things to be more efficient.
Right.
They don't care about what is the cost at one money lens. It's not about the cost,
Yeah.
it's about the efficiency. So we can figure out how much time it takes for an individual to become efficient at one particular task.
I would worry that people have such variation between each other that your approach will end up with not reliable predictions. And it's almost easier just to watch some people try things and make a prediction based on that.
For me, what I initially thought that can be used, for example, you're going to build a software system for a government agency, simply a dashboard. Okay, you have the data and all, you want to build a dashboard so that they can effectively use the data in day-to-day tasks. Right? Now there is a one way you can make a dashboard entirely in a descriptive way. Right? It will all be in a descriptive, like a part, like there will be lines like saying, other getting into color based, scheme based, theme based, right?
Yeah.
You know legends. In map there is a legend.
Yeah.
Yeah, so how to draft that particular legend? In a way it is much more easy for people to recognize.
Yeah.
Or what kind of science you could add in a software system so that people can recognize, okay, I'm clicking there, but what I'm clicking, I know the sound of a shrub while I will click on that will be different than the sound of wetlands.
This reminds me also of, I've got a project back home that's working with software that is used by air conditioning and furnace repair companies. Okay, so it's really boring, but there are these air conditioning furnace repair companies, and they have software like, oh, the customer at this street needs a new furnace, and I need to book their time, and do I have the supplies to build them a new furnace? And it has parts, and inventory, and warehouses, and you click through things. And they have made, the company's made software that works, but it's way too complicated. So their users are complaining. And so we've been hired to come make it simpler. And so we're analyzing clicks and where people we're trying to use machine learning to look at where the clicks pause. Like I'm on this screen and I go click, 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 and then I pause because I don't know where to go next. Right. And then it's not always easy to map clicks that you can measure onto constructs like confusion or trust or feeling lost.
So rather than building or something upon buttons, you can have something like a visual graphic system or sound-based thing. Now, it's not about the I want to wash my clothes and I have this is a sign cue that people associate with washing. So rather than building buttons which will have a common sounds, there will be additional piece of information where you can process it as kind of heuristic bias. So that sound means a lot of things, but while using machine, it always correlates to washing. It's basically creating a heuristic bias while using one program or another program.
Okay. Yeah, the applications are interesting. I mean, I think you'd end up with like, oh, this works well in certain contexts, but maybe not in others. Like maybe it works well in a engineering, assembly, manufacturing thing, but maybe it doesn't work well in hospitals. I don't know. Maybe it's fine. Yeah. I think it'll be easier for you to convince somebody of your software if you have an example.
Actually, I'm not trying to build anything out of this. It's
Okay.
just the idea that when I saw the task you have, and I tried to figure out what could be a thing I can design.
Yeah.
Then I realized, okay, this is the thing.
Yeah.
This is a game which can relate to that idea. Let's put into this
Mhm.
and try to get something out of this.
Yeah, no, that's right.
So just like that.
Cool.
I got a response and then with the variables and figure out what is the response there.
Yeah, and that thing when the game you showed me with the red and green buttons, there are studies back from the 50s even, you know, about that, about how long it takes people to adjust. Yeah. Let me go check in with these folks. Okay, thank you, Pranav. Hello, good to see you again. Are you here? We're going till 4. Is that all right?
Yeah, it is 4.
Yeah. Are you?
They are doing some activities.
Yeah, I was gonna walk around and check on them. Okay, so let's see. Are you okay? Good. Doing all right? Okay. Good. Doing okay? Doing all right?
We are taking out some points.
Okay. Good.
We're just still brainstorming.
Yeah. Well, good. It depends on how much time you want to spend, right? You could be like, I want to go fast and get it done now, and you just pick something and get it done. Or you can be thinking together a lot about it. Depends on what you want to do.
So what's the deadline for this?
Hmm?
What's the deadline for this?
Tomorrow at 2. Yeah.
So I'm still working on that. Can I ask you about this one?
Uh-huh.
I didn't understand here. Like this is something we've done for the first time, and this we need to go over it again to really understand this.
Mm.
This one, like here, evaluation / judgment. Again, this evaluation / judgment.
Huh.
So how do we?
That is weird. I don't know. I didn't notice that. That's weird. That shouldn't be there. I feel like it's like an error or something. I'll try to find the VACP article that I've got and send it. I bet I have a correction. Okay.
Like here, it's almost like technically when we are trying to dissect this whole exercise, it's as if we need to understand each one in a very clear sense. What is inspecting, what is checking, what is so that we were like learning it now, but it's not clarity still as to where to place it. We just did it as it came to our mind. Probably this is what it kind of.
Right. And if you do it more often or more tasks, it'll get easier because you'll start to realize like, oh, this is less than this task. You know, this is lower auditory load, this is bigger auditory load, and you'll start exploring it more. But I'll try to find the original article so you can read it. It'll have more information.
Right. So I have one more question. When we do a scale, usually they have an interval scale where there is equal difference between one and the next level or something like that.
Yeah.
Here, how do they arrive at like this 4.3, 4.9, and then suddenly shoots to 6.6?
Yeah.
How does that?
I don't know. I don't know how they got those. I think that this was from the Air Force in the U.S. originally, and they just had tasks that were related. You know, they had Air Force tasks, and they said, "Oh, this fits about here," but they didn't have tasks for every number value. Yeah.
So this one, like another thing is, say I was trying to connect it. This is an artificial exercise for me, the game.
Yeah.
That is basically to understand.
Yeah.
But if I were working in a hospital somewhere, and there is say a receptionist sitting at the table. It's not like she or he is doing a very complex task, but she's sitting there and she has to interact with say 20 people who are on her head at the same time.
Yeah.
And each one is demanding something and they're not following any discipline.
Yeah.
So that's also
Yeah.
that person is a complex task.
Yes, that's right.
So like practically where we cannot say no, you're going to come in a line, they don't listen, and sometimes we cannot control crowds. So I was trying to understand how do we use this to because it depends on a lot of the person's characteristics.
Yeah, that's a good question. The VACP for like multitasking and multi-human interaction. And I don't know if they ever did that because it was mostly like pilots in a cockpit, you know. So I feel like I want to Google that some. And it could be, I mean, on the very first day, I had some articles by this guy Salvucci about multitasking. And it could be that that's a better approach than the VACP thing. Because then if you're modeling it like multitasking, like here's the cognitive load of doing this task. And then when I switch to a new task, I have to like stop that and remember where I am. And then I have to boot up this task, right? And it could be that that's a better model for your receptionist. Yeah. I'm sorry, I don't have clear answers. But I like your example, the receptionist example.
So if there's anything that you would maybe not immediately now later that you would, because it's sounding very interesting as to how to put that in an organized way to analyze that
Yeah.
an encounter.
Yeah. Right. Yeah, I don't know.
And so is it right to say, like, if we do something like using this VSCP, would there be a argument that no, this is not applicable to this? Why
Yeah.
did they use it? Would that?
I mean, you could say that. Yeah, most people won't have heard of VACP unless they're in the military, because it's more military.
So it's
But
not wrong in a sense.
it's not wrong, but but you might, if you were presenting it to the hospital, they might, you might say, okay, here's this method from the military in the U.S. They find it useful for looking at the load of different tasks. I've found it useful in your hospital. Here's how I used it. And if you have some interesting results, they'll say, oh, that's great, that's helpful. Or that if you don't, they'll say, why are you teaching me about that? Right? So it's got the theory has to do some work that's useful.
Yes.
Yeah, right. Yeah. Yeah. Okay. But I told you I would look for health-related stuff, and I haven't found any yet. So, but I got sleepy yesterday. I'm still sort of jet lagged. So, but I'll keep looking.
Yes.
Okay.
Thank you.
Thank you.
Our brain person could kind of unravel this issue.
Y'all okay? Okay. Are you okay? Your partner left you?
He has a meeting to attend, so he has gone
Okay.
outside. So we have come up with some few points, so few structures on which we are going to write the story.
Nice. That's good. Those are two. I was just going to show you. And so there's a lot on VACP and medical worlds. If you can type it, I just type that in Google Scholar and it comes up. So there's plenty to explore. Okay. I think I'm done, right? Yeah. Okay, so I think we're officially done for now. Any last questions? I think you can stay here and finish up, or you can come back and email me tomorrow. It may not be appropriate everywhere. Sure. Yeah, sorry. So it's not really that.
Is it over?
Yeah.